All right, so if you haven't put your video back on after lunch, please do so. We have our wonderful Luann back with us again for this next little section, which is on how to run a tournament, running a regional tournament. We know that there are teams out there who are struggling to find a tournament, particularly in the Queensland area. So if you're from Queensland, we specifically want to talk to you about how to run a regional. It is not that hard, is it, Angie?
No, it's not. And lots of fun.
It is lots of fun. It is lots of fun. So we have got just a few pointers on what you need to run a regional. So first of all, you need to get first approval. There's no point in running 3 regionals within stone's throw of each other. You know, we want to space them out and be in areas that teams can get to. And you need to adhere to the first guidelines and rules about running a regional. You need to set your date, location, and size. How many teams can you actually accommodate at your regional? If you've only got 2 or 3 rooms to do judging in, that will restrict your size of your tournament. If you are running a tournament of, say, 40 teams, you need to have 10 judging rooms that can accommodate them. You also need to make sure you're running a regional, at the latest 2 weeks before a national event will take place. Otherwise, teams do not have enough time to prepare if they get to move on. We don't want you to reinvent the wheel either. There are a lot of resources that the lovely Winona from First Australia has put together over the years. It's called FLL in a Box. And that has so many resources. That is the to-go place when you need to find stuff and how to do it. And you can also reach out to other tournament directors as well on the Slack channel, and you know, we're all here to help each other. You need to organise volunteers. You will need referees, you will need judges, you will need runners, you will need people to do pit admin. You know, depending on the size of your tournament, will depend on how many of these people that you need. If you're a school, teachers are a great resource to have. They can judge, they can ref. There is training available for the judges and the refs, as well as partner training as well. And, you know, if your judges or refs can't attend the training on the day that it is run, so Fred will run a training for all the refs, and you can't attend it, you need to reach out and make sure that you can get those people trained beforehand. It's not that hard. It's not that onerous. It's really not to do to be a judge or a ref. Yeah, attend the regional partner training as well about how to run a tournament and what's expected and all of that. Arrange lunch for your volunteers. That's something that you need to do. You need to make sure that you feed your volunteers, because you know they're going to be, particularly your judges and your refs, they're going to be run off their feet during the day. So you need to make sure that they're going to get lunch, tea or coffee, you know, morning tea, those sorts of things. Look after your volunteers. And then when it comes to event day, oversee the event as a tournament director, and just making sure that everything's running smoothly, putting out any fires if there are any. You know, suddenly we've got a team that had a judging session at 10 o'clock in the morning and 2 of their kids aren't there because they were still playing soccer or something. You might need to do a quick reshuffle and help get that team to be able to do their judging without stressed kids or something like that. Things like that. And most importantly, operate the tournament under first rules. Don't go making up your own rules about how the tournament runs or what you're going to do or how the judging sessions are going to be. If you are running an approved First Australia regional, you need to stick to the rules of the competition.
Something I would add to that as well is that it's not fair to the teams that participate with you if you change the rules slightly or slightly change how things are run, because if they are going to go on to a next level event, and it's their first experience of experiencing it how it's supposed to be because you changed it, it's not really fair for those kids. So making sure that you run the rules the way they are, and they're really simple, really simple.
Yeah, so let me just add my 2 cents here as well. This is Luann going on a little bit of a sales pitch. The limiting factor for First Lego League in Australia is going to be the events that we can run. We have lots of events that are already full, and we want to be able to reach even more kids. We want to be able to reach more students and give them this amazing opportunity. So that's why we added this in today, to just sort of encourage you that even if it's your first year, seriously think about maybe not this year running an event, but think about it for next year. It's not that hard. We do provide some incentives. So if you agree to run an event, then we waive a registration fee for one of your First Lego League teams from your school or from your group. So there's a little bit of financial incentive there. And we also provide the challenge sets on the day, which you get to keep afterwards as well. And we send you wonderful t-shirts and we send you these and all of those kinds of things. So you're not responsible for any of those sorts of things. The real financial commitment is lunch. And then if you have any venue costs, but most schools will let you run an event without charging you for it. So if you have any questions about that, please feel free to reach out to me or to Winona. We're happy to have a chat. We'd love to bring on more partners in the next year so that we can grow. And, if you're finding that you're having trouble recruiting volunteers, especially key volunteers like your head ref and your judge advisor, let us know that as well, because we have a number of people around Australia that are willing to help out in those roles, especially the first year, if you're feeling a little bit nervous about it. So that's my sales pitch. I hope that you guys have a great season. And after you get to your first event, you'll be so excited. Next year, you just won't be able to stop yourself from putting your hand up to say, yes, my school wants to do this too.
Yeah. One thing I forgot about is that you need to make sure you've got your DJ and your music and your MC, because that's what brings the party. At the robot game, I guess that's one thing that we've all missed from not having in-person events is the fun the kids have and the spontaneous dancing that happens around the FLL tables in between matches and things like that. Does anyone have any questions about running an event? Does anyone want to run an event?
I guess one thing that if you're sitting there today and you're thinking, oh, I'm not sure, possibly, put your hand up to shadow another event. Before I ran events, I volunteered as a judge, and that at least gave me a bit of a behind the scenes look at what needed to happen. And there were certainly things that I made sure were implemented into events we run, because I saw how when it was run a certain way at other events, it made it run smoothly. So, if you're thinking about it, whether it not be for this year, I mean, this year would be great because we do need more events, but if it's for next year, put up your hand to shadow one of the current regional partners and, see what it's all about.
Oh, and absolutely volunteer at another event and go and be judges. I know that whoever is running that other event will be very grateful to have volunteers, someone else coming along to help judge. So Luann, we have a question of, are you happy to receive a message on Slack, on the Slack channel about if they've got questions later on about running an event?
Of course, definitely. And let me also encourage you to reach out to Winona, because she's the one who manages most of the events, but absolutely reach out to me as well. That's good. And I would say one other thing, I've been doing First now for many, many years, and I never go to an event that I don't learn something new about running a team or how to do something better. And so it will actually help your teams a lot as well, because you will learn so much just by doing this that you can, I just really want to encourage you, if you have any inclination to do this, get involved and just jump in the deep end with the rest of us.
How do we find out other events where we can shadow at? So
I would suggest contacting the event. So on the First Australia site is the list of who the tournament directors are for the different events. So I would reach out if there's one that's closest to you. I'd reach out to that tournament director. Central Coast, always happy to have people come and help out. Shadow, no problem at all. Happy to drive an hour either side of Sydney. Reach out to ProjectB or Team Apollo.
Someone has commented, I'm just around the corner of a school that already runs an event. So there's probably, well, volunteer at the event.
Volunteer. And look, as we grow, we are going to have to start having more events in similar places. Years ago, we used to have 3 events at Macquarie University. It was just on different weekends. So that works out well also. I also want to say that if you're concerned about volunteering, if your team doesn't make it to the national event, maybe think about volunteering there, because we need heaps of volunteers at that event. And if we can have experienced coaches actually in there doing the judging, whose teams are not competing, right? That's really, really good as well.
All right, any other questions?
Yeah,
Right. Okay, so what are we up to next, Andrew? We are up to Andrew's robot design and strategy. We're going to spend a bit of time on that, and then we've got some of our FLL kids coming to help demonstrate how we run on the table in a bit of time. So Andrew's going to take the lead. So I'm going to switch chairs.
Okay, everyone. So we're now ready to begin with how to actually build this robot. Now, there's a couple of things to go over here. Now, if there are any team members still listening, do remember that this is, again, how we do it. It's not necessarily the best way to do it, but it works for us. And we've been able to use this approach to train other teams. Now, I would say in 80–90% of the time that we've been outscored on the robot table is by teams that have taken what we've taught them and then improved on it, which means our kids are usually there cheering them on all the more. So feel free to take this and tweak it to suit what you guys do. So up on the screen right now is 2 versions of how we build robots. Team Apollo's version and Bucephalus's version. So Angie, you just want to give a 30-second rundown of how yours work?
Yeah, so when we're looking at the robot game, we divide the team up into a couple of different roles. One is the robot analysis, who oversees all things robot and is the decision maker between what the robot needs in order to have the programming happen, the strategies to work, etc. So then we have a strategist whose idea is to work out, what strategies are we going to use to complete the missions and the strategy around the gameplay. And then we've got mechanical engineer, or this year they've affectionately called her the Tinkerbell, because we have a new person moving into that role, and she's a bit of a tinkerer. So they, as it suggests, they're the one that's building the pieces. They're not the only people that do that, but that's sort of how they work that role, how they work those roles out. The rest of the team's always giving input, but there's sort of 3 main people that will facilitate making sure the jobs get done.
So every team has their own flavor of doing this. So we're going to share both. So we're going to get a bit more detail about how we do it. So we divide our team roles into 4: core robot, pathfinder, strategy, and software. So strategy is responsible for analyzing the missions, and they also plan and document each run from base. When I say that, they're listing where the robot's supposed to go, what motors are used for what missions are used, and details like that. They also are setting what the robot needs to have design-wise to work, what sensors it needs, what its size needs to be. They're also mapping what the attachment needs to do. what each attachment, what its specs are, what it needs to be able to do. Now, they then give that information to the other groups, and then they are responsible for actually building the attachments as well. Now, kids can belong to more than one team in this group, but this is a role. So by achieving that level of documentation, like just a quick sketch of this robot goes from here to here, it has to use motor R to do this, this, and this, and motor L left to do this and this. Anybody can then proceed to build that attachment. Attachment design requirements also includes the template that we use to base all our attachments on. So every attachment is built from the same root, and then that goes out and does other, and then they're modified to do specific jobs. So having that done, once you've done the initial backlog of this is what we're doing, they then get on to actually building things. Pathfinder. So at the same time, strategy is doing all this analysis. Pathfinder builds a really simple robot. So it might be, if you're using EV3, it might be Riley Rover from Damien Key. Right? Only deal is it's got to have similar sensors to the robot that you're planning on using. And your job is to get that robot to reach the areas of the board as nominated by strategy. How you get there, what's the best way to get there? Are there more than one way to get there? Try it out, see what happens. They don't actually do the missions. They're all about travel. Any specific code requests they have, they give the software. And once the core robot is finished, the code the Pathfinder writes gets adapted to work with that core robot. So again, all these four roles are happening at the same time. They're passing information to each other. So our first robot game day, our first session where we're at the table, I'll have some kids picking apart the missions. Others will immediately start with Pathfinder, core robot software. They will all be active from day dot. And if I've got a 10-person team, there's enough in those four roles to give everybody a job to do from the very beginning. Right, so then we get to the core robot. So after talking with strategy to figure out what the build specs are, the core robot team has to build the actual robot that's going to do the competition, plus whatever it is they're going to use to attach things to it. That's their job. Then they have to test it. So we're talking, put it down, have it go forward 3 rotations and turn. Does it end up in the same place every single time? So we're looking to make sure the robot's performance is stable and consistent. If it's not, there's a bad balance or a wheel issue or something like that, they've got to go back to the drawing board and fix that. So if our robot goes wrong, we want it to be for a spectacular reason, not because the robot is overbalanced. And their other job is to test the code that Pathfinder puts together and identify the differences. So if the Pathfinder robot uses a different size wheel, well, we just got to add every drive distance by an extra bit. If the light sensors are a different position on the robot, we just got to do some adjustment. So basically figure out what the adjustment is so that all that Pathfinder code can then get converted into actual competition code. Comments helps that process immensely. Then we have the software team. Their job is, first of all, to identify common programming tasks. So drive forward until my force sensor goes off would be one. Line follow would be another. Gyro turn or gyro drive, like common tasks that you're going to need to do a lot of. They then have to identify parameters and functions to make that code reusable. So I don't want to hard code a gyro turn that can only do 90 degrees left. I want to be able to specify the steepness of the turn, the number of degrees, and the power level and direction it's heading. That's reusable, and that's very helpful. They then have to write what we used to call a MyBlock library for the team. But now that we're not just stuck with MyBlocks, it could be just basic. You're building a software library that the team can access. So not everybody on the team needs to know how the line follow works. Just My software team wrote a line follow method or function or my block. I use it this way. And again, they're sharing with Pathfinder, so they can sort of feed off each other, improving each other's roles. So hopefully Pathfinder starts out without any code library. They're just trying to make things work. But as software library develops programs, Pathfinder can actually test it exclusively in real world conditions. And also work with Core Robot to do the same thing. So by doing all those 4 roles, we're able to give a 10-person team a meaningful robot job from the first meeting. And that works quite well for us. Right. Anyone got any questions on Apollo's roles or ours before we skip on?
I need to get onto the computer to do that.
There's no questions in the Slack or.
Okay, then we'll move on. Right, basic principles of robot design. How not to have things go horribly wrong. So there's a lot of advanced principles, but this is the basic stuff. And often the advanced kids need a reminder of the basic stuff because they get too ambitious and forget the little things. So you would be surprised how many people forget this part. Make sure you can charge and download code to your robot. The number of times we've seen kids with perfect robots and then we have to dismantle it so we can charge it. That is not fun. Secondly, if it can come apart, it will, and at the worst possible time. So you want to make very sure that this thing is stable and strong. We used to have the rule, it should be able to survive the drop test. If you drop it on the way to the table, you do not want it shattering into a million pieces. Now, this one is less of an issue with Spike than it was with EV3 and NXT, but it's still a very good thing to have in mind. Your light sensors, you generally don't want them exposed to light pollution. So if you're able to shield them in such a way that driving over sunlight or light levels in a room change things, that's a good idea. Now, spikes with the bright LEDs are less vulnerable to that, but it is still theoretically possible. My team still has generational trauma from the first time that happened to them. It was part of the reason we did so badly in Delft. We were on a stage and there had massive theatre lights out, and our robot did not have a shielded sensor, and it was literally blind on that field. And we didn't know enough to know what the problem was. So be aware of that. Test it. I said it's not as big a problem with Spike as it was with EV3 and NXT, but just be careful. Now, if you are using EV3s, please learn how to calibrate your light sensors. If you don't know how to do that, send us a message afterwards and we'll show you how. Right? Calibrating those sensors is really, really important because the light levels where you're working might be perfect, but you go to a competition and it will be different, particularly if there's a lot of glass windows. Okay, shielding the sensor. Linda, can you hand me one of the EV3 robots? Yep. Okay, so I'm just going to stop sharing for a moment and I will spotlight me. So this is one of our old EV3 robots. We keep it around as a reference point. It's not actually used in competition at the moment. So it's got a touch sensor on the front and sensors underneath. Now, as that drives, there is no way for external light to get to those sensors. You can see there's an extra beam around the bottom here. We can extend that around the front to shield it further, but basically external light cannot get to those sensors. No. So this is pretty solid. It's designed to not break. If it does drop, a piece will actually crack and shatter. It's happened before, but the robot itself will stay intact. That answer your question, guys? Yep, awesome.
Number 3.
There we go. Okay. Right, now, when line following, you want, unless you want to deal with really complicated code, you want your light sensors to be in front and outside of the circumference of the drive lines. It makes it so much easier if that's what's happening. Now, it is possible to do it otherwise, but I wouldn't choose to inflict that on a team unless it was really necessary. Also, robot balance. That's also important. If I can have that robot back in a lid, Lyndall. Yep. So here's the main robot. It is currently balanced. So its tipping point is between the rear wheels and the front. So it's balanced in between here somewhere. As a result, it is not going to tip forwards. Yeah, that's the camera. Yep. So balanced on the edge. It is currently sitting balanced on the edge of that table. That's where it starts to tip forwards. That's where it starts to tip back. So it is balanced pretty much perfectly there. And that means the robot's performance is a lot more consistent. If there's too much weight forwards, the robot will tip forward every time. It accelerates backwards, it can tip over. So if I go like this, you can see the robot still tips where it needs to go.
At the moment, that robot doesn't have its back wheels.
Yeah, it doesn't have back
So
wheels.
it's not-
Yeah. Yeah. So to answer that question, someone just asked, is this information we're allowed to share with the students? With the camera back up.
Sorry.
Or a mental and problem solve? This to me falls under the don't make rookie errors thing. Tell them this is a problem, then let them figure out the best way to solve it. So if I tell my team a balanced robot is a stable robot and is consistent, I'll let them figure out how the best way to make that happen. And if they insist on doing it their way, then hey, they can find out and deal with that themselves. Not a problem.
Was there a question about the light spark lights?
Yeah, so that someone did report Spike did have an issue.
Yes.
Right, drive axles. I'm gonna need that robot again, sorry.
Gee.
So we support both sides of the drive axle, outside and inside. That's one advantage of using those shells. If you're supporting both ends of the drive axle, the part that's hooked into the motor and the part on the outside, your wheels are not moving through the transition. The movement is a lot more reliable. Also, your gears, your axles tend not to bend over time. So it's always a good thing to try and do. Gyro drifts. It is a big deal with EV3. We've actually managed to have some cases of it happening with Spike too in recent weeks. Not sure if that's a firmware change issue or something else. Identify what a gyro drift looks like and know how to fix it. Again, that's something else. If you want to know about that, contact us and we will talk about it. Basically, though, it's when the gyro sensor thinks the robot's moving and it's not, or vice versa. And that does happen. So if your gyro is being strange, you might want to look into that.
Even with Spike gyro.
Yeah.
We've had gyro issues this week at classes.
Right. Now, robot designs using angled controllers are a pain to work with. We always, you saw in our robot, that brick was horizontal. It's a lot easier to build off.
The wheel
Yeah.
size.
I'll get to that now. And beware overbuilding. When our kids are designing attachments or robots, the first go through, they will always make the robots too big, too many pieces, too heavy, too unbalanced. We usually make them build it a second time. The rule is the first time through is not going to be right.
What improvements can they make?
What improvements can be made? And this one is actually pretty important. When you make your design it for fast attachment changes. Bear in mind how the robot's actually going to be used. You can have the greatest robot on the planet, but if it takes you 60 seconds to swap out attachments, you're not going to do well at all.
Do you want to show the?
No, I'll do that next one.
Are,
Actually, yeah,
are
give me
there
the
height
attachment.
limits to the robot?
So to answer the questions that have come through,
We've
large
got-
wheels or small, it depends. Large wheels tend to give you speed. But we had a huge trouble with them for precision. So my guys always tended to go for, we want precise movement with sensors, and big wheels were a problem with that. So we went back to little ones.
Yeah, I think even using the larger spike wheels, they had issues with the precision of line following with the larger wheels.
Oh,
So
and
this was-
there it's the great debate of Team Apollo. We have
Yep.
50% of the team wanting small and 50% of the team wanting large. Every year, when the judges ask, were there any difficulties you had to overcome or any problems you had to solve? That's guaranteed to be the thing they say.
So this is what we mean by attachment for fast swap out. So-
Okay, forward that now.
Wrong
Sorry,
way.
backwards.
There we go. There's the robot. This is our attachment template from that year. Every attachment was built based on this piece.
Show the
here.
underside, show the underside.
So like that, it sits on the robot like that. All the attachments were built onto that frame. So when it came time to take the attachment on and off, you just did that. Wasn't pegged on, was gravity just held it on. Now, if you're building a forklift or something that clips on, you want to adopt the same type of principle. You want on and off. You don't want to have to fiddle around with multiple pegs.
I think one of the biggest time things in the robot game is your changeover time of things rather than what the robot does on the field.
Exactly. Height limits on the robot. There are height limits for the small inspection zone. There are not height limits on launch. Tips to turn to your, oh yeah, so with anytime you're using a gyro turn, the speed is going and momentum is going to play a role. So our general rule for turn to gyro is move at about 20% power, I think, for a spike.
20 to 30%.
Yep. And always under turn by about 3 to 5 degrees.
Yeah. You want to turn 90 degrees, we turn 85.
So Angela, if you want to send us a message later, we can show you a bit, or we can get our kids to show you how they work on that one.
Test if you use multiple robots, test each robot because each one will have its own sweet spot.
Yes. And if you've got an unbalanced robot, it'll be a complete nightmare trying to figure out how it all works.
Oh, yeah.
Okay, so that is the basics. So any team member, if they keep that in mind, should at least have a decent way of dealing with that. Oh yeah, so Ben, so if anyone wants to put a message up on the coach Slack and asking Ben about how the wheel types work, I think I've seen that report, haven't I, Ben? You've published that before. There's some pretty good stuff in that.
We were just volunteering to hold some wheels up in front of the camera and do a short.
Oh,
discussion.
okay. No, we won't do that. I haven't got time.
We're running
Yeah,
out of
sure.
time.
That's all right.
So basic maintenance tasks. So if you've got the right robot, how do you keep it right? So test your motors and axles before use and keep testing them during the season. No two motors are the same. They may look the same, but they are not. So you want to bear that one in mind. And a lot of axles get worn and twisted over time. So you want to make sure that they're always consistent. All right. Now, dirty tires, they will let you down, and they will let you down a lot. So if you're using EB3, use clear sticky tape to lift the dirt off the tires. When it comes to spike, we've had a lot of success with baby wipes, just to clean the muck off. Do be aware, though, that you've got to have the tires completely non-sticky and dry before you bring them to the table, or you will suffer the wrath of Fred. And you may also get some. There was some kerfuffle a while back about if you're using tape that leaves adhesive on the rubber, are you actually giving your robot an advantage? So you want to make very sure that's not happening. So we just use very weak, very cheap sticky tape, and that's enough to lift the stuff off it. Then you run it across a clean surface a couple of times to make sure there's nothing left behind. But yeah, dirt on the tires drastically changes your performance. Drive axles will be worn down way faster than you think. And you can always tell just how uneven your robot was when you crack it open at the end of the season and find motors and axles covered in ground down plastic, white Lego dust. It happens quite a lot, actually. So you once you use drive axles, they have a change. Yeah, once you use them for driving, you're probably not going to use them for anything else ever again. Right, firmware and software. There are going to be changes, but for the love of all that's good and wholesome, do not update them right before a tournament. Particularly don't do it at a tournament. You are asking for trouble, and a lot of it. If there is an update, don't blindly do it. Just check it out first. Don't mess with what works unless there's a really good reason. Right. Anything that moves will wear down over time. We've got in FRC, our FRC team has a shelf of shame where they keep parts that have been worn down or broken during robot operations. We've got something similar with our Lego team. Gears that have teeth worn almost completely off. They're buried in the guts of the robot, so you don't see them until you take the robot apart at the end of the season and go, oh, that's why the gears were slipping. So you want to make sure that anything that moves you can get to and swap out, because you will be running that robot thousands of times over the course of the season. Right, connections and strain on cables. EV3 was particularly bad for this. If you were rough on the cables, you could get a bad cable. That everything worked, but the cable was just faulty. So, yeah. I've not been using Spike long enough, but I've yet to see any cable damage to a Spike kit, because the cables are a lot more flexible. But I'm going to say that it's quite likely they can get damaged, so treat them carefully. Charge your robot between matches. If the robot is not on, make sure at a competition, make sure it's charged. Charge your robot between sessions when you're building the thing or when you're testing it. Otherwise, you will come to the situation where robot works beautifully at the start of the day. It changes slightly as you go on. You make some changes. It's all good, all working perfectly. You're all happy. You go home. Next day you come back, robot's fully charged and nothing works because you had it tailored to work with a low battery. All right? Keep your robot charged. Don't let it drop too low because it will also affect how your robot performs.
Oh, the number of times our kids are going, it's not working anymore. We go, what's the battery level? Oh, it's only 20%. Oh, there's the problem.
Yep. Right.
Andrew, we've got a couple of questions that have come through here.
Yep.
One is, can you use stickers on to label your robots, for example, Robot 1 and Robot 2?
Is Fred still here?
No.
No. Okay, well, last I checked on that one, markings is allowed as long as they're not big and flashy.
Mm-hmm.
Discrete, I think the word was discrete markings are allowed.
Yeah. And then there is also, how many times would you run your robot in the competition?
So there's 3 goes at the table. You'll sometimes, and there are usually practice tables. So you have to book time on a practice table. If your robot is running beautifully, you may get an extra 2 or 3 goes on a table. Like, it's generally safe to run it once when you get there, once after your first run, and then maybe one before your final run. But if everything goes horribly wrong, you may be spending a lot more time on the practice tables. I also saw cable. No, I've not seen cable changes to yellow if left in sunny or close. We typically don't have our robots outside.
Where it's sunny.
And what was the other one?
Alcohol wipes.
Alcohol wipes. I have not seen any issues with that, and they're just baby wipes we use. So
Well, you sometimes use the disinfectant wipes.
sometimes use disinfectant wipes. We've got nothing left. We have not detected any damage.
But drunk robots can't be any better than drunk humans, right?
Cool. Okay. So strategy, basics. If you learn nothing else from anything we do, remember this first point. Never rely on dead reckoning, ever. It creates very many unhappy children. Dead reckoning is when you're not using sensors. You're just relying on wheel movements to take you where you want to go. And if you're running on a fresh mat, like at a tournament, what works beautifully at home will not work at the tournament. Now that we're getting back to in-person events, I'm predicting we're going to see a lot of that particular issue again. Secondly, never expect a robot to drive straight on their own, particularly if you're using a spike and one of those omni ball things at the back. It's like a shopping trolley. The robot is not capable of running in a straight line on its own. It might come close, but you can't rely on it. Back wheels. Yeah, you got the caster wheels like on a shopping trolley, or a slider wheel, which is a solid wheel that can't turn but slides across the ground. Both of those work differently. So caster wheels will spin, you'll turn much easily, but you have a lot more trouble driving in a straight-ish line. Slider wheels will move straighter, but have a bit more friction on a turn. Have we got a robot with slider wheels on it handy? There's got to be wheels.
Yeah, we've got last ones.
Yeah. Right. The wall is your friend. If you're able to use it, it's effectively an extra sensor. The wall will never move. It will always be where you expect it to be. And if you can stay in contact with it or square up on it, you gain yourself an advantage. Now, as to what a slider wheel looks like, this was the spike robot our kids built, I think,
Last year.
This is a slider wheel. So when the robot turns, this slides across the ground. When it drives forward, it just rolls. So this gives us a bit more friction. You can see the dirt and stuff built up on that, but it does help us go in a straight line. That's their preference. Some teams prefer the caster wheels.
Or the omni wheels that come with the
Or the
kits.
omni wheels that come with the kits. There's no right or wrong way on that one. It's just a style.
Number 2.
Right. When you're launching, some people like aiming jigs. Other people prefer launching from the same position every time. Somewhere that's got nice, easy landmarks and doesn't require a lot of human intervention to get right. So if you're launching your robot and having it off by a tiny bit means you miss, that's probably a sign you're doing something wrong. Make sure the robot starts in, and also if every launch starts from the same type of place, it's a lot easier on your technicians to get it working. So that's one of the reasons we build our robots with those flat backs that you saw. It's really easy to push them up against a wall and start from there. Right, planning for error tolerance. This is something that takes a bit of thinking to get used to. So let's use this year's field as an example. The toy factory has a great big funnel on top of it. As long as you get the energy cell somewhere in that funnel, it's going to roll down and score. So it's got a pretty big error tolerance of where it's got to go. On the other hand, a lot of the other places, you haven't got that much space to get it right, and they can roll out of the way really easily. So when you design your robot, if you have to hit a space that's 2 to 3 studs wide to achieve your mission, that is not enough error tolerance. You need to do something to make sure your robot will work given the maximum amount of possibilities. So a template that guides you in a position if you hit something something that forces you against a wall, all those type of things. Or if I'm going to pick something up, I'm not going to go in with one pole. I'm going to go in with a pitchfork. 3 prongs, 3 chances to get what I'm trying to grab. So yeah, tell your kids to plan for it not being where it needs to be. Now, when it comes to missions, go for quality over quantity, right? Nothing's more demoralizing than being able to achieve 20 missions, but a run only getting 1 of them or none. Make something work every single time over 6 missions that work every time over 20 missions that work maybe half the time. Take some chances. Like, I'm going to go out and this run will reliably get 6 out of the 7 missions. That last 7 is a bit of a gamble, but we thought it's worth a shot. We're going to see what happens. That's fine. Right. Much to my disappointment, Lego is not a high precision equipment. Now, I keep holding out they're going to give us a laser distance sensor at some point, but that's probably not going to happen. So bear in mind, yeah, back to the error tolerances thing, you are going to need to account for variation. And practice your robot runs, right? The number of teams I've seen get to a competition and the first time they've run under tournament conditions is at the tournament is way too high. Have the kids do the practice at home when they can still make changes to their code and their movements to speed things up, or they can drop missions. Right? The practice makes a lot of difference. Our kids typically will choreograph where they're standing, who they're handing stuff to, and timing changeovers to look for places they can do it more effectively. I think Apollo does the same, don't you, Ange?
Yeah, we definitely do. And it often means that we realize that some runs or some missions that we had put together need to change, because when you're doing your change or your choreography, it all, you realize that there are just differences that need to be made. So it's another iteration point.
Okay. And anyone that's ever done anything with software, for the love of all that's good and wholesome, back up your code. Version control is even better. So when one kid, a Spike does automatic saving. So when you accidentally save something you didn't mean to and wipe over something, you want to be able to go back. If you can't, just save different versions of the code.
So yeah, every time we go to use the code each day, we make sure we've saved it as that day's date as soon as they open it, before any changes are made, so that the previous one was the last date at its last save.
That's on top of any other innate version control or stuff that we use. So yeah, be incredibly paranoid. Coaches, this is something you can do for your teams. Get their code, save it. Do not leave it on one laptop. We had one team lose all their code due to melted chocolate in a bag with a laptop. That's something the girl is never going to live down. So yeah. Okay. So that's the basics. We're going to go into a little bit more advanced stuff, and then we'll move on to the other sections. Any questions on any of that? No? Okay. So this is something that your kids can do. This is how we teach robot, and this is how we teach robot planning. So this process will be up with the PDFs, and you can copy it or improve on it. Take your pick. I'd really love feedback on how this works. Our kids have been using this for over 10 years now. So when we're designing our robot, the first thing we do is we don't touch the pieces. We look at the field and ask ourselves, what is the shape we want our robot to be? So this is one of those strategy team questions that we had with the roles earlier. Do I want a narrow or wide robot, a long or a short, a tall or a low? Now, if there's a tight spot I need to drive between, I want a small robot. If there's a mission that requires me to be tall, that requires a lot of reach upwards, maybe a tall robot is what I need to get there. For City Shaper, we had to drive up a bridge. So we wanted to make sure our robot was actually narrow enough to drive up that bridge. So that's step one. What is the basic dimensions for your robot? Step two, what sensors do you want to use? Oops. Remember I said that walls are a sensor? Look at the field and see, is there a place where I can use a wall? Now I can run along it with contact, or I can run into it and square up on it. All I need is an open section where I can get to a wall with nothing between me and it. That really helps and will tell me, do I want a robot with a flat surface? Are there lines to follow? So this year there are lines, not as many as there've been in previous years, but they are there, and the lines touch most or come close to most of the missions. So to my team, that would say, yeah, being able to line follow is pretty important. Oops. Objects to square up on, not just walls. Which sensors are the most useful? So we are going to go through a sensor configuration examples in a little bit, but I will tell you now, we used an ultrasonic or a distance sensor our very first year of competition. We are now in our 13th season, and we have never used one other than that very first season. And there is a very good reason for that. Now, that said, if your team is able to use a distance sensor accurately, reliably, and to a good purpose, I want to see it, and the judges will definitely want to see it. But the distance sensors tend not to be as good as you want them to be. We were very disappointed. So you've now got robot size and basically how the robot's going to perceive the world. You then look for highways. Now, this is where if you've heard me talk about this before, you know I harp on about this a lot, and that's because we're very big on precision movement. We don't want to see teams running off base, running on dead reckoning. We want teams to be able to reliably get to where they want to go. So a highway is anywhere on the field that is reliable, easy to navigate, and easily accessible. It doesn't have to be a line. I mean, with the gyro sensor on a spike, you could just have a straight path down the middle of the field. That's still a highway. So what you're looking for is landmarks, navigation marks, anywhere you can get to every single time. Now, for example, here's my mouse on the red. Can I annotate on this, can't I?
Mm-hmm.
There we go. Yeah, I'm going to drive out this way. Now, if I gyro drive in that direction, I know I'm going to hit that black line at some point. I won't know where I am north to south, but I know I'm on the line. But if I just shoot straight across, I can hit that, and then I can turn up or down and figure out where I am from there. Right? Trying to follow the lines through this. The lines are obvious highways this year, because there's so few of them. So get your kids to identify where the robot is likely to travel. And then you combine that with navigation points. So again, we're big on precision. So there are 3 types of navigation points that we run off. A strong point is when 2 or more sensors agree on where I am. A medium point is when there's only 1 sensor that agrees, or I've done a dead reckoning move after a strong point. Weak is I have no sensor information. So if I was driving out from launch to the hydrogen plant, that would be weak because I have no sensor lock to figure out where that goes. If I was driving out, like I said, to this one, that's medium. I've got 1 sensor that tells me where I am, but I don't know exactly where I am. I have a general idea. And this one is a little bit trickier, but let's assume, okay, we'll use this one. Let's say I am running along a wall, and then my touch sensor hits that. The wall tells me where I am. The touch sensor tells me where I am. That's a strong point. I can guarantee I know where I am. So the goal here is to identify every strong point on the field. Now, if I have 2 color sensors on the front of my robot, like on the ones I showed you, every intersection becomes a strong point. So if I'm navigating on a line like that, my other sensor will see that line, and I can line follow until the second sensor sees that intersection. That's one reason my kids prefer the double light sensor approach, because they can do that. Now, whether or not that's useful this year because there's not as many lines, I don't know. They haven't decided yet. They may be going with a touch sensor to hit stuff and 1 color sensor. We'll see what happens. Now, the general deal here is that rotations do not count as sensors unless another sensor is involved. So if I'm wall running for a number of sensors, the kids would normally regard that as a strong-ish point, but they're always very suspicious about wheel movements because wheels can slip as you drive. So at this point, I now have what my basic dimensions are going to be. I have what sensors I'm going to use, and I know roughly where I'm going to be moving around the field. So these questions all tie in with those roles we had at the beginning. Step 5, that's where I start to pick apart the mission models like we were doing with Fred. So in our game, the strategy people or every team member gets assigned a mission to grab one model and analyze it, pick it apart. What movements activate it? I got an up and down or a left and right or a spin, or I just run into it. How many directions can I approach it? I'm not talking about how I get there. It's about what side of the mission can I activate it from. With the hydroelectric dam this year, do I have to activate it from the side? Can I do it from the front or the back? Is the mission near any others? Can they be clustered? Particularly if I'm on a strong point, can I reach out and do multiple missions from that point? This one is the biggie. Can the mission be activated without a modem? Right? If I'm using attachments, can I activate that without needing any power at all? I just drive into it with a simple machine or elastic bands or something like that. And then lastly, what's the best way to reach the mission? How do I get to that point? Then the kids compare notes and get a list of what are the common movements needed and use that info to plan more of their robots. So if I can do every mission on the field with an up and down motion or by driving into something, there we go. Then we plan our runs. So that's an example from one of our documents from World Class many, many years ago. You map out where the robot goes and you map out when the robots are going to be strong, medium, or weak. You want to find ways to reach strong where you can, and you want to do missions from strong points if at all possible. We do one of these for every one of our runs. And again, that comes down to the documentation of everybody knows what the robot's got to do. Then we get to actually touching the Lego. We play with robot layouts. Now, a few of you have seen me do this before. We give the kids the motors, the bricks, and the sensors. We do not give them any pegs or parts, and we get them to start playing with how the parts are going to sit together. Right? The goal here is to find a pattern that you like. An overview, all of this comes down to knowing what your robot needs to do before you build. Right? We want to integrate, you want to integrate all the motors, all the sensors into the design from the very beginning. You want to avoid the very, very common mistake of slapping some wheels on the robot and then figuring out where do the sensors go. Do it all in one go. Now, this is a lot of thinking, right? And you want to test it as well. You want to test it over and over again. Like I mentioned with the rolls, does it turn reliably? Does it drive reliably? Does it perform consistently? Doing all this stuff will give you a robot that will perform reliably, and it will look really good for a design judge. Now, on that note, one last thing. Some teams will include sensors on the attachments and hot swap them during the competition. That is allowed. There are no
Yeah.
limits on attachments.
Where though, how long it takes you to do that, and that they get the right cable in the right holes.
Yes, the right cable in the right hole is important.
Something I'd just like to add at this point, though, too, is that everything that Andrew has described up until this point, we're all panicked about not having our tables. I would say that a good percentage of it can be done with the resources we all have at hand right now. We have maps of the field with grids. We have, you know, you can see the missions both in the video, both from what Fred's shown us today, by the build guides. You can work out how they all work. A lot of these questions can be answered right now, and you could build some, you know, lay out your robots, build your robots, test your robots now, even before you have your field ready to go.
Yeah. So I've got, I think we're dealing with about half dozen teams at the moment, and all of them are moving through this process, and none of them have got their table.
No one in Australia has.
So by the time they get their table, they're going to know exactly what it is they want to build. We'll just drop back onto this test robot performance thing. So that's make your robot drive forward 2 rotations and stop. Mark it with a peg or something. Do it again and again and again. Does it always end up at the same spot? Turn 2 rotations left at 67 turning. Does it always end up at the same spot? Running that kind of testing eliminates a lot of variability in your robot performance. Takes maybe 20 minutes and saves you many, many hours of heartache. Okay, so here's some sensor configuration examples. That's actually a picture of our robot from City Shaper. I don't recommend trying to put that many gears onto a robot unless you've got someone that's a little bit crazy on your team, because maintaining that was a pain. But it can be good. Okay. Use sensors. Use sensors, please. For the love of all that's good and wholesome, use sensors. It gives you better navigation, better results, and much, much happier children. If you don't know how to use them, ask. Any veteran team in Australia will be more than happy to spend time with you and show you how to use those sensors effectively. So we have a couple of examples we use as good layouts. So this is the basic one, a touch sensor and a light sensor. You can follow lines and you can run into stuff. Works quite well. Then we have the reversible one. If you've got 4 sensor ports available, or just 2, depending if you're using a spike, a color sensor at each end, your robot suddenly doesn't care which way is front or back. And there are teams that build entire strategies about never having to turn around. Right, the dual line follower. So you saw that on the robots I showed you. If the 2 color sensors are close together, you can line trap. That's when you're following both sides of a line at the same time. That makes for a lot more accuracy, but it's also a lot harder to get lined up. If you spread the color sensors out, you can offset line follow. So I can follow with the left sensor and the bulk of my robot is to the right of the line, which is really good if a line is close to another object. Also helps me with squaring up on a line. If I come in at an angle, all I've got to do is steer until both sensors see black and I've got a reasonable line up on the line. So there's no great advantage either way on that. It just has different qualities. This is what we used, my kids tended to use for the EV3 robots. They put a gyro in the middle, touch out the front, and 2 color sensors. They weren't line trapping, it was far enough apart to help them with the offset. This is what my kids are using for spike. Still not quite on the line trapping approach. If they can, they'll try and use medium motors for attachments, but they'll use large if they haven't got any spare mediums. And they'll stick with the 2 color sensors and they'll use the onboard gyro. So they ditch the touch sensor. As I said, though, this year there's still some debate as to whether they want to go back to using that. So there are two types of spike motors, large and medium, and they both got, the medium motor is smaller, you can build a smaller robot, but there's a bit more grunt in the larger motors. To drive, we'll always use the mediums. One of the teams did try and drive on a large robot and did try to drive on large motors, and they had a lot of problems that they didn't have with the mediums. So I haven't looked hard enough into that, but it's generally not we don't recommend it.
Someone is asking what a gyro sensor is and how does it work?
So a gyro sensor measures turns. Like an accelerometer gyro sensor, it measures how far your robot turns at once. If you'd like to know how to use it, send us an email and we'll do a crash course for you.
So the Spike Hub has it inbuilt in it.
Yeah.
Yeah.
Essential motors, I've seen them, I haven't tried them. I don't know how they perform under load.
They're very small.
They're very small.
Have you played with the bench?
The essential, like the Spike Essential ones, yes, and they can be connected to a Spike Prime. Why you would do that?
They're tiny.
Yeah.
Yeah. I don't know. I have not seen any load testing with them to know how they perform in a competition. But we don't actually have any of them, so our kids are happy with what they've got, so I don't think we will.
Yeah, I don't know that they would work, and they definitely can be plugged in, but I don't know that they would give you any benefit.
You can test it for us, Sharon, and find out. Yeah, I have seen some really skillful teams run with 3 color sensors. That makes for really superb line following. It's a strategy choice. What do you lose? I've actually seen one Japanese team several years ago, back before Spike came out. They had 4 color sensors out the front in a line. And so the Japanese teams tend to scare me. And they did really, really well. This was their first Fuji-san. They've won a couple of major championships, so they know their stuff.
You wouldn't be able to do that with Spike, though.
No, you can't do that. Not without sacrificing motors.
Yeah.
Yeah. So it's definitely a viable option. Okay. So now this is a little bit about how to create robots. Then we move on to how this actually works. So I'm going to skip through this a little bit. A little bit behind. So this is something we invented called robot class. Now, some of you guys have seen this before, and that's okay. We've made a couple of changes to how we classify things. This is mostly about how you design robots overall. This is like a strategic choice before you start building anything. So with robot classes, this is something we use as a classification system for robots. We add new classes as we see new types, and none are better than any other. It's just strategy choice. And a robot can belong to more than one class or sit between them, because FLL kids are weird like that. They come up with all kinds of things you don't expect. So when we say standard robot, we're referring to a robot with 2 motor-driven wheels, 1 or more unpowered sliders, and can use extra motors for manipulation of objects. An attachment is anything that integrates with the robot that alters the ability of the robot. It's usually powered by a motor, but not always. And a frame, which we don't see too much of these days because the rules sort of make it a lot harder, is basically a vehicle that's operated by the robot, and it's usually bigger than the robot. So most teams will stick with standard robots and attachments. So a class 1 robot is a standard robot without sensors. All right. And this will always be one of 2 things: a beginner team that doesn't know how to use sensors, or a super uber team that has figured out a way mechanically to solve all the problems on the field without needing sensors. So it's either really, really good or really, really bad. So they navigate by dead reckoning alone. They have attachments with clip on or off, and all tasks are performed by robot movement or extra motors that can be simple or not. So this, won't worry about sound, I don't think. So this is Food Factor from several years ago. This robot has no sensors.
This was not our robot.
This is not our robot. So it's using the wall. You had to get you had to leave the baby fish in the ocean. So they took all the fish out. They clip off their attachment. So this is not a style I would recommend because it obviously takes a while to make the change. This was the year that they got a nice starting point by touching the two walls.
And you also had a rectangle base.
Yeah. Now it's going to come out again. It's using the wall as a navigation tool. It picks up all the bacteria and traps them. Brings it back. Picks a different program. Puts the attachment back on. You can see pegging stuff on and off does tend to get very awkward. So if you can figure out a way to attach without pegs, I highly recommend you do it. And now to solve the problem with the fish, they put the baby fish back in. And put it back on its mark. So all that was done without sensors. It's achieved maybe a sixth of the board, not a lot, but it's going to work every time and they're going to score points. So it's not necessarily a bad choice, you're just not going to score very high. So obviously you've heard me talk about dead reckoning being a bad idea. If you're going to do this, you want to keep the programs really simple, really short, and use solid objects to reduce error. Now, I don't recommend you do a class 1. Class 2 is where I would suggest a lot of you start. So class 2 is a simple robot with sensors and a built-in core movement. So this was our first robot. It was a forklift. We drove around with a forklift. We ran into stuff and had up and down movement. So attachments slip on and off easily. Your core movement is planned to do most of the missions, and the robot does the work. So this was our first robot game. Yeah, most of you have probably seen this already, but if you have a look at us run the first couple of missions, we come out, we hit something. That hand should look very familiar to everybody. So down goes the forklift, we run in, and back we come. Back in the base, we slide stuff on and off the prongs of the forklift. And we do the next mission by, again, running along the wall, running into something and doing up and down, and then we run into something again. All right. So that's a class 2. So class 2s are actually very, very effective. You can outscore a lot of really big robots with a well-planned class 2. Downside is it's a little bit harder when you've got a large team to work with that because everyone's waiting for their turn on the robot. As to the question from Angela, the rules were different back then. You could touch the robot when it was partially in. Right? Don't ignore those rules. That was just about how that worked. Yeah. Class 3 is sort of halfway in between that. I'll skip over that because it's probably not the greatest thing to mess with. Class 4 is the other one we recommend. So that's the type of robot I was just showing you. Built-in core movement. So a class 2, we had a forklift built into the front of the robot. The forklift wouldn't come out. It was like a core part of the robot itself. Now this here, a class 4, has a core robot, not a core movement. This is the core robot. Everything dropped onto this. So we had, this is what we call a frame. It's a really big attachment. And this is a little attachment. The idea is, like I showed you on that example, every attachment drops straight onto the robot and is driven by these dog gears here. If you want to see how to do that, we're more than happy to do an offline lesson for you. So here's an example of that working. So this was one of our practice runs from last year. So the robot is inside that big frame. We catch the chicken. We drop off the turbine. You can see deliver the package to the doorway. We're actually going to fix the railway with a cannon just for fun. Yes, we shot the railway. Lego cannons are a lot of fun if you get them to work. Grabbed the packages, left the chicken behind. Now we can't pick up the robot until the string's in base. There we go. There's our core robot. And there goes that second attachment I showed you. Really fast changeovers, because all you got to do is drop on and off. And all the different tools does things. Okay. Now, a class 2 robot, a class 4 robot, has some substantial advantages, particularly with a large team, because you don't all need the robot to be doing work. Each pair of kids can work on their own attachment, and somebody else can do the core robot itself. Everybody's building at the same time. Does that make sense to everyone? But it is a lot harder to organize and plan. So that's where we're at. Okay. Yeah. So I've got to go run and do another call for a moment, but Lyndall and the others can talk about how that works. We're also going to run through how a robot game actually works on the day. So if anyone wants to see, when we get to the questions at the end, if anyone wants to see those robot runs I just did in full, more than happy to do that for you. And we can probably show you some up close how it all works. So now I'm going to hand over to some members of the PV FLL team, and they're going to run you through running a robot game.
Okay. I'm just going to stop the share and hopefully not make you all too seasick as I do this. So we have got Faith and Isaac, who have both graduated from FLL. Do you need the tripod extended? I need this somehow. Give me a second. All right, we've gone through if we're going through the tripod. Yeah, it's fine. All right.
Sorry for the moving camera, we're just getting the tripod adjusted.
Yeah, I'm sorry about that. All right, hopefully. So we have made a mock-up of a field. Let's see here. Yeah, we have made a mock-up of a field. So we have our red and blue. Can you show that face? So red over here, blue over here. And so the chicken is our dinosaur. Yep. That starts there. And our blue things might be some energy or something that's sitting on the field.
Yeah, the various mission models.
So we have Carolyn and Scar from our FLL team. And I said Isaac and Faith who have graduated. So they're going to run through what happens at the table.
Yeah, so there are a few changes with how the procedure works this year, as there's the 2 launch areas. But generally speaking, the whole process is mostly the same. So what you're going to do at the competition is you'll be in queue waiting to go to the table. And you should have everything you're going to use during the match. And this should be your robot, any equipment you're going to use. You're allowed to bring up to 2 sheets of paper with notes or information on it if you want, but you're not allowed to bring a computer or a tablet or any other electronic devices like that.
Or a second robot.
Yeah, you're also not allowed to bring a second robot. You can have only 1 robot and then as much equipment as you want, provided it fits into the size restrictions. So the first size restriction is that all of your equipment at the start of the match must be able to fit into both launch areas. So if we grab the equipment, put it in, we can stick it in both launch areas, and that's all well and good. That's the default. However, you get a bonus 20 points if all of your equipment can fit into one of the launch areas and is under a height limit of 12 inches, which is about 30 centimeters. So about here. So that's a pretty decent area and try and fit stuff into. But you may run into trouble if you have larger attachments. Now, your entire team is allowed to help with fitting stuff into the single launch area. I would recommend that you practice making sure all your equipment is going to fit in if you're aiming for the small inspection bonus. And you are allowed to hold all the pieces in place. It doesn't have to stand up on its own.
On that note, also practice getting from small inspection to setting up for a run. Especially if you're used to doing it, filming a robot match, you have a bit more time. Whereas in the live competition at the table, you only get 2 minutes to be set up and ready for the match. So make sure that you can be as close to that time limit as possible.
Yeah, so once you've gotten all your stuff ready in one or both launch areas, and the referee has checked that it's within the height limit, your team then needs to split up. So half of your team goes to the left launch area and the other half stays at the right launch area. During the match, so once the match starts, nobody can switch places between these two groups. If you want to switch out technicians, you can switch them out with the half of the team that is standing on their side of the table, but you cannot have anyone cross to the other side of the table during the match.
So if we're swapping out, say Isaac or Caroline, you come around here. Caroline didn't start over there. Caroline started over here. So I'm gonna want to swap out with Caroline. So I take a big step back and Caroline can go in.
Yeah, but neither Caroline or Charlotte or Faye could come over to this side and swap out with me. Because I'm the only one over here, I'm the only one who can be a technician for this side of the table. Because of this, it's generally a good idea to make sure that you split your team in half evenly. So as part of that split, you also need to make sure that you put your equipment in the starting areas or home areas where you want it to be at the beginning of the match.
So if your robot's starting on this side of the field, make sure you start your robot over here. Don't have the technicians on that side hold it because you can't pass it back over.
Yeah, this is something I'll get to in a moment. So I'll do it over here and I'll just get this set up. Yeah, so we've got our robot here. We've got an aiming jig that we're going to use to make sure it's lined up properly. And we've got an attachment that we're going to put on the robot. So we get the robot set up, put any attachment on that we want it to have, line it up with an aiming jig, and then we're ready to go at the start of the match. So you wait for the referee or the timekeeper to count down 3, 2, 1, Lego. And on the first syllable of the word Lego, that's when you can press the button to launch your robot. When your robot launches, everything it's about to use needs to be inside the launch area, and you cannot be touching or holding anything. So if you've got an aiming jig here, you're not allowed to hold it down while the robot leaves. It needs to be sitting there on its own, and you just press the button and the robot launches. Also, if you do have an aiming jig, it does need to be completely inside the launch area. It cannot extend off the edge of the mat into home.
So you can't have something that uses the wall of the field inside home to line up. You can only use this wall here.
Anyway, so we've got this set up. Got our robot here. 3, 2, 1, Lego. It launches, goes out, does some missions, and it pick up some mission models from the field, and then the robot comes and finishes in the other launch area. So now that the robot's there, you can take the attachment off. It's
The Duplo. There we go.
Yeah, and you can put a different attachment on different equipment. You can do whatever you want with the mission model. But a very important thing is technicians are not allowed to touch anything outside of their home area. So those mission models that the robot picked up there, these two little bits here the robot picked up, they're now in the blue launch area, in the blue home. So me and Faith, who are over here in the red home, we can't reach over and grab these, and those two can't pass them to us either. The only way to get those mission models back to the red launch area is if they travel with the robot. And the same is true about mission models that start in home, for instance, the dinosaur. So you might get this robot set up, ready to go, holding dinosaur, a couple of the mission models, an aiming jig.
Somehow, what has happened?
You just drop out.
We just, oh no,
Oh,
there
no,
we go.
okay.
We go back.
Right, there you go.
Wrong button.
So you got this set up, ready to go. You're going to line it up against the aiming jig, and then we have it launch. It comes out and does the missions and stuff, comes around, does whatever it wants, it comes back here. Now that it's back in this launch area here, the technicians on this side can use these mission models and get them set up for whatever else is going to happen. So you could have decided to deliver the dinosaur launching from the blue area, deliver it and have the robot come back without it, or you could use the robot to ferry it to the red launch area and then launch a mission holding it from the red launch area.
Dinosaur runs in the red.
Yeah.
As long as the dinosaur ends up in the red side.
You get the points.
Yeah. So, but now the important thing is, even though that red attachment over there started in this launch area, now that it's over there, we can't touch it anymore. Only the blue team of technicians can use that unless it comes back with the robot. Yep. Good. So now at the end of the match, during the match, rescuing the robot.
So it gets caught in the middle of the field.
So if the robot is stranded in the middle of the field and you need to interrupt it and rescue it for any reason, either set of technicians is allowed to pick it up and return it to their launch area. It does not have to be the one it started from. It does not have to be the one it was going to. And your team can make the decision whether you're going to try and attempt the mission you were just trying to do again, or if you're going to skip over that one and try and start the next one or do something completely different.
Yeah. So if robot launches from here, got stuck somewhere in the table, Caroline can go and grab the robot and bring it back to the blue launch area. But then I can't go and grab that off of Caroline. It's got to be launched from blue.
Yeah. Now, this may be subject to rules updates. I don't know what the intention is behind the ruling, but it may be a valid strategy to launch the robot from one launch area and then intentionally interrupt it and bring it back to the other one if you want to save time with transferring objects, or if you want to, if you think it'll be more reliable to do so. It is very important to remember, however, that you do not get to keep anything that the robot picked up while it was on the field. You get to keep whatever it started with in the launch area. But if this robot came out here.
So, Caroline. So if the robot started in here with the blue little piece on it, and then it came over here, picked up the green one, and then Caroline needed to rescue it, or even I needed to rescue it, I could keep the blue block, but the green one has to stay there, or the ref takes it, and then that game piece is no longer in play.
So guys, we've just had a question here. Can you verbally communicate between the two sides?
Yes,
Yes,
you're allowed to communicate as much as you want. The only restriction is they are not allowed to switch sides, and they are not allowed to touch anything outside of their home area.
And I would say that the ref will be looking for your gracious professionalism amongst your team if you are communicating. Are you talking to each other in a nice way, or are you yelling at each other?
Yes. So do you practice communication between the people who are your robot runners?
Yeah. And then at the end of the match, when the time limit is up, wherever your robot is, it'll need to stop what it's doing. Either the referee will deactivate it or ask you to deactivate it, or if your program has already ended, you can just leave the robot sitting there. And then you need to make sure that at the end of the match, you leave everything that's on the field outside of home exactly where it is without touching it until the score has finished being taken. And everything inside of home, you want to make it visually clear what all of the mission models you have inside of each launch area or home area are, and separate them from your equipment so the referee can clearly see what's where and how they should be scoring you.
Also, please do make sure that you do not take game pieces from the table when you do pack up your robot. It has happened before, and it is a pain to chase down teams who've taken something because they haven't realized it was still attached to their robot.
Yeah, number one priority at the end of the match is turn off the robot. Number two priority, make sure you don't have any mission models still attached to or inside of your equipment.
Yeah.
Once the referee has finished going through the score sheet, they'll confirm it with your team's technicians, and one of them will need to sign it off with either the team's name or their initials or however you want to do it. Once that sheet of paper is signed, then you're good to go and start packing up your robot.
So,
Yeah.
Was there another
Any
question?
questions?
Not another question, but something I was just going to add that I have seen happen a number of times too during robot games is teams get very used to practicing on their table, running a mission, it not working, and they reset their mission. But during a robot game, you can't reset missions mid game. So whatever state it's in is whatever state it is in. So that's part of that, as Faith and Isaac were saying, practice running the robot and getting used to working out what to do if a mission doesn't work mid game.
Yeah, definitely 100%. That's a part of the rule of you can't touch anything outside of your home area. That includes all the mission models on the field. Even if you attempted a mission and it failed, or the robot crashed, or it broke it off its dual lock, or something went catastrophically wrong, your team members cannot touch the mission models on the field. You cannot reset it. You've got effectively one attempt at each mission. If it goes wrong, then it's gone wrong. You can either make a robot so that it can deal with that, or you can just move on to the next mission and try again.
on that note, if while rescuing your robot, you accidentally set off a mission or knock something astray, the referees can fix that.
Yeah, but that's the referee's decision on how they choose to go about doing that in the moment. And your team members should not be resetting the field during a match for any reason. Even at the end of the match, there will be volunteers whose job it is to reset the field. It's the only thing your team has to do is make sure you don't have any mission models with you, pack up your stuff and get out of the way so the next team can come in.
Yeah.
And pack up quickly.
Pack up quickly, because again, the next team only has 2 minutes to set up, and the longer you're at the table, less time they have to set up.
Yeah. Something you can do if you have delicate equipment or it needs to be packed into a box a certain way is start by just getting it all off the table. Maybe give a different piece of equipment to each team member and just get out of the way. And then once you're away from the main competition area, then you can focus on putting everything in the right spot in its box.
Yeah.
Okay.
Do we have any more questions?
Well, we do have one more thing to go over.
So the rule about jigs extending over the mat, would two separate jigs doing that be illegal? Sorry, would that be legal? E.g. one jig
So
off
are
the
you
mat as
talking
a spacer?
Yeah. They're doing it like if you have a spacer in here that fits completely inside of home, and then another aiming jig touching that like that. I believe that would be allowed, but that would most likely come down to what the referee at the table has to say about it. unless a ruling update gets released at some point between now and your competition. Yeah, I'd say it would most likely be allowed, but make sure you have a backup plan if the referee says you can't do that.
Yes.
A robot game is 2.5 minutes. So at competition, you'll get 3 2.5-minute games throughout the day, as well as your 30-minute judging session. So your judging session normally will happen in the morning, and then you'll be getting through your robot games. Be a bit slower in the morning, getting through the robot games, but in the afternoon, they try and get through them as quickly as they can, because they need the final robot scores as part of the deliberations and scoring for the judges.
So on the note of scoring as well, only your highest robot run counts. So if you completely bomb out on the first 2, but your last one works perfect, that's fine. Those first 2 aren't going to be counted against your score. And also, it's how the missions are at the end of the match that counts for scoring. So if you do the mission and it's done perfectly, and then your robot goes out of control, barrels into it, and undoes the scoring condition, you won't score that mission because it's not in that set condition at the end of the match. So you want to make sure that you avoid undoing your mission scoring.
Yeah. The most common cause of unscoring a mission is a team delivering a mission model to a target area, and then later their robot goes out of control and pushes it out of the target area. So if your robot looks like it's about to unscore a mission, it's generally a good idea to try and interrupt it before that happens. Because if you don't interrupt the robot until after it's already moved something out of a scoring condition, then the robot did that, you can't undo it, and you just have to leave it as it is.
And also on that note with interruptions, if you interrupt your robot in a way that makes it look like the interruption itself is what caused that mission to score, you may not get the points for that mission. That is up to the individual ref.
Yeah. So yeah, be careful with interrupting the robot. Make sure that if you're interrupting close after activating a mission, that you make it obvious that you interrupting the robot is not what allowed it to work. For instance, if you had your robot coming along here and you were pushing something into a target zone,
Imagine this, my hands on the target zone.
yeah, if it's coming along here and then you interrupt it and it leaves it inside the target zone and it looked like the robot wasn't going to stop, the referee may not give you the points for that mission. If on the other hand, it pushes it in and then has clearly stopped moving and then you interrupt it, you would get the points for the mission because the robot had left it in the target zone.
All right. Does the robot need to come back to the home base at the end of the match?
No, it does not. At the end of the match, your robot can be wherever you want. However, if the program is still running at the end of the match, either you or the referee will need to stop the program from running to make sure the robot doesn't score or unscore any missions once the time's finished.
You also need to be aware of what the scoring condition of the mission that you're finishing at is, because if it says that it shouldn't be touching anything, you need to make sure your robot is not touching the thing.
Yeah, and on that note, if you do stop the robot, don't pick it up and then put it back down, because again, that can change the scoring condition of the mission and it does make it harder for the refs to figure out what's going on.
Yeah, so you are reaching out and stopping the robot's program at the end of the match does not count as interrupting it unless you pick up the robot or move it in some way. If you're just pressing the stop button, that's fine. If you actually grab the robot and move it and change the condition of the field in any way, then that counts as an interruption.
All right. I think that's all we have time for with the robot, running the robot match. Is there any final questions for these guys? Not just a thank you. Well done. Thank you, guys. And we'll get back on with our next section, which is, I think, Angie, you're going to talk to us about Discover and Explore. I just need to figure out how to give you permission to control. Just give me 1 second. I need that moved to where I am. Yes.
I'm doing it.
Yes, approved. There we go. Have you got control, Ange?
Hopefully. Let's see.
All right. Hang on. I need to unpin me. How do I do that? Where's my
Remove spotlight.
Yes, I want to unspotlight. Yes.
There we go. Okay, so I'm going to have a little chat to you guys now about FLL Discover and Explore, two sections of the FLL program that are a little less known. So I'm just going to talk through, but I am aware of that we're running over time. So I'm going to go through this relatively quickly. One thing that I will say, though, is that if you do have questions about this or are interested, whether you're a school group and you're thinking, oh, this could be great for our younger years, etc., please reach out and we can go through some more information about this. So while Project Persepolis have gone up the age groups in their teams, Team Apollo have gone down the age groups in their team and cover these areas. So there we go. Okay, so our first one that we're going to look at is the first LEGO League Discover section, and it's actually an area that a lot of people don't even know exists. So this is for our 4 to 6 year olds. So this is preschoolers and early stage 1 in schools, or your kindergarten classes, depending on where in Australia you are from. So the idea is that this is a introductory, let these kids discover what STEM is all about. It's designed to ignite their curiosity. It is designed to be entirely a learn through play system, and that through playing with this Lego and completing a variety of different challenges, they'll learn not only about STEM, but they'll also, so they won't only just learn some basic STEM principles, so for example, physics around force, etc., but they'll also develop some really great habits of learning. So things like learning to work in teams, listening and speaking skills, how to problem solve, how to persist when things go wrong. So this program, as I said, is designed for 4 to 6 year olds. It involves them, as you can see in this image here, it involves them working with just Lego, just Duplo Lego. So there is no robotic component to the Discover section. A lot of people say to me, oh, my 4-year-old builds with regular Lego. Why would I give them Duplo? The reason is that we are trying to take away the complexity of building by using Duplo, because Duplo is a lot easier, and therefore the difficulty and challenges they have become more about the concepts rather than difficulties with building complex parts. So in terms of what actually happens in the first LEGO League Discover, so this is not a competition. These are, you have an expo or a festival at the end of the season for these guys, but basically it works very similar to First LEGO League Challenge. So students work through a theme for the year, and it's the same theme as First LEGO League Challenge, so it's super powered as well. They come up with, they learn about the idea, and so you can see from, this is this year's mission models, so you can see there's a fan, very similar to on the challenge board. Here is a little house representative, so the idea is that they're going to learn about energy sources. We've got an energy power plant, so they're going to learn about energy sources and look at how we interact with those. They'll come up with ideas about how to solve problems that they can see, but really they're not actually being asked to solve problems, they're just being asked to identify where issues might be and really just learn a little bit about these. As well as, so when you register a team, you will get that year's Discover field kit, if you like, mission models. But you'll also need to utilize what is the Lego Duplo STEM Park set, and any other Duplo pieces that you have, you are welcome to use within this set. So the kids basically get the parts and they will build an idea, a story, something that they can tell. So if you think about the Lego movie, it's the idea that they'll build a scene and be able to tell their judges or their reviewers a little bit about what they have learned through the process. So, oh, clicking's not working again. There we go. So they do use the design process, and this is what we say, this is where they're discovering about it. So they're exploring an idea, they create something with mission models, they create a little scene, and they share it. We're not asking them necessarily to share with professionals at this age group, 4 to 6-year-olds, although I know some that could hold their own, definitely in a boardroom. But sharing with the rest of their school, sharing with family and friends, that kind of thing, as well as sharing at the expo. So the expo is really a celebration. You'll have teams with tables of their models built, and they can go around and share and look at each other's ideas and what they learned. So I've got the video here. This one, wait, stop. Okay. This one is having a look at how all the mission models come together. Let's get that.
I don't think I enabled sound on the share. Sorry.
That's okay. It's just the Lego music. There's no talking anyway.
Yeah.
So you can see these guys have their models. They're going to be learning about how different parts work, and they're just playing. And in that play, that natural curiosity about how things work, that natural learning, it's kind of more that raw, organic, how does this work? Why does this do things? You'll find with this age group, when they build their scenes, it's built one way today and tomorrow it's a totally different way. Off that one. Oh, there we go. So there are meeting guides and engineer notebooks for this age group as well. I personally wouldn't bother with printing out or having access to the engineering notebooks, because most 4 to 6-year-olds that I know aren't interested in writing, particularly if they're interested in building. But the team meeting guides are a really nice little lesson guide or session guide to follow along. So each session starts with a big question. So it's that inquiry-based learning, a question that you're going to ask them that will get them thinking for the day. It then moves on to what are called the 6 brick warm-ups. So Lego Education have come up with this 6 bricks program. Basically, every child gets 6 bricks, and they're the 6 bricks you can see here. And each time they are set with a challenge. So, for example, the first challenge might be, can you build me the tallest tower? Now, all the kids will naturally just stack them one on top of the other. And then you say to them, that's great, but can you build me a taller tower? And so then they've got to think about, well, do they actually have to click together? Can I turn them on their sides? Can I turn them up-ended? Oh, hang on. They never said I couldn't partner up with someone and build an even taller tower. So it's getting them to think outside the box and think creatively. They'll then go through and explore, an element of that year's theme with a set task that will be around discussion and thinking and finding out new things. They'll then create something, and then they'll come back and share what they've built before packing up, which is really, really important. One of the things with the 6 brick program as well, the idea is that each child gets a 6 brick set that they get to take home and share with their families, and there are a series of games and activities that they can participate in home, which are lots of fun, and it gets your families involved as well. So to take part in the First Lego League Discover program, when you sign up and register a team, it's a lot cheaper than a challenge team. So it's $75 to register for a Discover team, and you will get your Discover set, which is the mission models you saw in the videos with the kids playing before. You'll get your Discover mat. So it's just a cardboard mat that they can set up their scene and idea on. You'll also get your 6 brick set, which are called the Discover More sets. You will need to purchase separately the STEM part set. This set is recommended for up to 4 students. This is what you would need for each 4 students. A team for Discover is, I think that's on my next slide, is you can have 2 to 4 players or 2 to 4 team players per team, and an adult coach. The key part is that it is for 4 to 6-year-olds. Obviously with that loose parameters that First Australia often endorse, in that if you've got, a 3 3/4-year-old who can participate, then that's fine. but you know, we don't want to see 7 and 8 year olds in there doing this part as well. So as I said, what you need, your Discover build set, the Lego Steam part, and then any Lego pieces that you have around. You can utilize standard Lego, so it doesn't have to just be the Duplo, but the recommendation is that it is so that you take out the complexity of the building. And the end result can be one of two ways. So you usually will hold an in-house expo. So let's say the idea is that you run it for a whole class, but they're broken up into small groups within the class. At the end of your season, or at the end of the 12-week program, you would set up a little display within your school or within your group. If you're a small team on your own, you might meet up with some other teams as well. Some of the regional tournaments, some of the regional FLL challenge tournaments will have a section for Discover. Anyone who's on the Central Coast or registering for the Central Coast, there is a Discover section for there. And that's just, as I said, a way for them to showcase what they've learned and what they've discovered over the course of the program. And as I said, it's all about discovering the world of STEM. So no robots, no coding, just all about the STEAM experience. So the next one, as we move up age groups, is FLL Explore. And this one is moving into that next age bracket. So for those kids who are past that Discover, but not quite yet there with the challenge section. So it's for groups of children that are ages 6 through to 10 years of age. And you'll notice there is a little bit of an overlap between Discover and then the upper end is with challenge. Teams can be up to 6 players, so 2 to 6 team members on a team. And the idea is that they learn the fundamental principles of engineering. So we take that step up. They not only learn, they're not only discovering about engineering and STEM and whatever that year's theme is, but they actually are going to identify a problem. We do use a robot in this particular program. It has been in the past the We Do up. Linda.
Whoops, sorry.
It has been in the past the We Do 2.0, which you are perfectly welcome to continue to use if you have access to one. However, as they are starting to be phased out, replacement has been the Lego Education Spike Essential model. So basically, again, we do go through the same design process. So again, we're trying to introduce the concepts. So you'll often find that kids that come through from the Discover or the Explore section into the Challenge section, they're all over this because they've had the time to spend a little bit of concrete time on learning this design process. So similarly, they'll explore that year's theme. They'll come up with design and create a solution. These guys will add in that test element, test how it works, test what actually, goes wrong, what doesn't go wrong. Again, share that. In this age group, we are wanting them to start sharing that outside of their immediate circles of, people in their ideas. So they might start talking to professionals. They might have an excursion somewhere where they can share their idea. And then again, they share it at an expo. So these guys also, both sections, Discover and Explore, do also have the exact same core values that the challenge section have. So they will be looking at developing those skills in teamwork, skills in innovation, impact, inclusion, fun, obviously, and also all the discovery. So you can see here, once they've gone through exploring the idea and they've come up with an idea, they then create a team model. So the little photo here is a photo from one of our Team Apollo junior teams a few years back. And you can see there's this idea, this sort of story that they had. So this one was from City Shaper Year, and it was called Boomtown for the Lego Explorers. And the idea here was that the guys had created this story that was about everybody having their own little home, their own little town in a community setting, but there was a community garden. And If you wanted to access the community garden, that is get some food from the community garden, then you had to also contribute to the community garden. So each time you contributed to the community garden, that might be weeding, planting, watering, then you could get tokens, and you would show those tokens to the Spybot here. So this was their robot built out of the WeDo, and the Spybot would either flash red and make a horrible sound and say, no, you can't go in, or it'd flash green and say, yes, you've got the right token, you can go in. If they were allowed to go in, they could then move, hop into the elevator and be lifted up to the garden. And again, this was motorized by a WeDo as well. So the team could explain to the reviewers, their judges, as they came around, what the story was and what it was that they were trying to achieve, what problem they had come up with, and how they decided to solve that. So again, I've got a video for this year's models, so you can see what it's like, and you'll see that it's taking that next step up from the Discover, but it's not quite at that challenge level yet. So you can see there are similarities to the models within the challenge set. The fan that has, that releases energy tokens, a carousel that can be powered by the energy plant. And here they're showing you that those parts can either be manually operated, or you can attach a WeDo or a spike elements to it to operate these. Part that's probably a little bit different to challenge is that for these guys, they actually design a team poster, and this is put up in their display area. So their team poster reflects what they explored, their journey through that, and how they've gone about sharing it. So again, here is a poster of from Team Apollo Juniors. And so they shared, we've got lots of photos, lots of information, a drawing that they did deciding their problem, the cycle of their problem, their coding that they use, and here was a little story that they had. One of the things that is required as part of their review process is that they talk through how their coding works, how their robot operates. They also need to discuss what elements are in their model, how does it all work. They are supposed to include simple machines in there, or be able to identify the simple machines. The models themselves have simple machines, but again, it's that idea of introducing some of those STEM concepts to them. So, and for them to start to be able to understand that whole design process, and that they can talk through what happened there, as well as identifying the core values. How did they go about teamwork? How did they go about discovering? What did they look at? What do they think their solution will have as an impact? So start with the Explore program. What you will need to do is register a team. Again, it's $75 to register a team, and you will get your superpower mission model set, Explorer set. You'll get your mat as well. You can choose to either use the WeDo or the Spike elements. You'll also need a device that you can code on, an iPad or a computer. One of the things about both the Spike, the WeDo and the elements are that they are Bluetooth operated rather than via cable. When are you clicking behind me?
I'm trying to admit someone, so sorry.
That's okay. The other thing there was craft supplies. This is the age group that want to build and make and create things. So that's a really essential part. That's why I put that in there. So again, for this group, you can have up to 6 people. They have to be between the ages of 6 to 10. You will get your Lego Inspire mission model set when you register. You will need to purchase yourself either the WeDo 2.0 or the Spike Essentials. And again, same as in the challenge section, you can only use Lego branded pieces. Once again, there is not a There is not it is not a competition. It's an expo. And again, a lot of regional events will host an expo, and there is always a national Lego League Explorer event at Macquarie University at the end of the year as well. And so again, it's about just exploring those concepts of STEM. So I know I've rushed really, really fast through all of those ideas. Were there any questions about those? I've seen a couple pop up.
So what about a 5-year-old turning 6 this year?
Yeah,
Can they
look,
do Explore?
personally, I would say perfectly fine. I think that would be perfectly fine, and I think that would work quite well. You know, one 5-year-old could, one 5-year-old couldn't. Some 5-year-olds could quite easily handle challenge, you know. So it really depends on the individual child. But yes, you definitely could have a 5-year-old in there as well. Yeah.
And then there was the question, there is a mat, so no need for a base plate.
So you can use the mat however you'd like. So a lot of them, so in the Inspire set that you get, that's what they call their sets, the Inspire sets. In your Inspire sets, you will get your grey base plates. You'll get 9 of those grey base plates. So you can still lay them out, but there's not that need to have the set restrictions of the set size of a base plate this time. So you don't have to have the big ones, but you can still use that if you choose to.
And Ben has an Explore team meeting as we speak.
Oh, we could have had a demonstration.
Okay, anyway, we need to move on. So I'll go back to sharing. So now we were going to spend the next an hour and 20 next bit of time having a deeper dive into project and core values. And again, if you've got any questions, then we'll do a question time at the end and talk about some additional resources that are out there. So thanks for sticking with us so far, guys, and hopefully we are giving you a lot of information. So what makes a good innovation project and what makes a good presentation? Those are questions we often get asked. When we find out, we'll tell you. There's no right or wrong way basically to do a presentation. And there's, I guess, really, as long as you can bring your innovation project back to the theme, back to the questions, there really isn't a wrong project. And I think this year is one of the most open-ended themes that we've had for a while as to what is around. And we are constantly getting new ideas and new approaches as we go. And something that may be perfect one season, the way you approach the project, may absolutely not work the following season at all. And so we have, over the years, the kids have come up with what they call the unofficial rules of the project. It doesn't mean we can't do better or you can't do better. But yeah, I'm going to have a look at those with you. And just remember that core values should be shown throughout everything that you're doing. So the first unofficial rule is to research your project. Read the rules, look at the engineering notebook, look at the challenge guide, and understand what you can and can't do. The year that we did was food factor, water was not allowed as part of that. We had some kids come up with a great idea about a way to improve water in third world countries. And then they went back and read the challenge document, was like, no, that was not allowed. So I don't think there's anything that's not allowed this year in the energy journey, but yeah, make sure you understand what's happening. Don't fear the rubric. In fact, use the rubric, keep going back to the rubric. Answer the questions that are on the rubric. Make sure the kids know what's there. When they're putting together their presentation, make sure they've got a copy of the rubric. Make sure that they know they've got to clearly define their problem, talk about their research, talk about their solution. Make sure they know they've got to have something to show the judges about their idea. It's not that hard to hit the high notes if you know what you're looking for.
Research, research, research. Again, with the research, you can't do too much research. Again, if you're just relying on Google, you're not going to do as well. Find people to talk to in the community, find professionals, get someone to come in and talk with the kids, do some experiments, see what they can set up, see what they can do, see what they can play with, where their idea takes them. The more sources you have of research, the better. Involve as many professionals as you can in your project. Email them, Zoom with them, or Skype, or however you can contact them. It's amazing once you start talking to people out in the real world who I just love talking to the kids. We often have to remind people to, that with our professionals, that it's going to take a little while to talk to them, because the kids will not just talk to you for half an hour. They'll go to an hour or two sometimes. All right. Milk it for all it's worth. So every team has their own opportunities and perspectives, such as location, hobbies, jobs, contacts, opportunities. Just like Andrew did at the beginning, looking and thinking about different things. Find out what's unique to your community, to your kids. Use that as part of your research, or even in the presentation, what you can do there. Start with passions. Basically, if the kids are not passionate about what they're doing, they will not want to do it. They will get bored with the subject and it will be a chore. But if it's something that they're really passionate about, they will love doing it. Last year for Cargo Connect, my team looked at transporting cakes. We had many cooks, many kids who like eating cakes, making cakes, decorating cakes. And so they had a lot of cake during the season as we did experiments with how to keep cakes from going smash in a car. They were passionate about it. They were driven. Nothing was too much. But yeah, we have had one year, I think it was the Trash Trek year. That was a very hard year for the team there. They weren't really that engaged with it, and you could tell they weren't as excited to come and do what they needed to. So rocket-powered wheelchairs are cool. This is something from our very first year. Don't restrict your ideas to being sensible. Sometimes the crazy ideas are the most fun. You just have to treat it seriously. So with a rocket-powered wheelchair, they would need to look into aerodynamics and rocket fuel and safety and all of those sorts of things. So if their idea is a bit out of there, but they can do the research, they have the story to tell, they can link it, and they've looked at it from all different angles, fantastic. Good on them. And never underestimate the power of an idea. Don't be too quick to dismiss an idea for an innovation. Many good solutions come from ideas that initially seemed lame, uninspiring, and just a lost cause. Sometimes that idea that they had right at the beginning of the season, 2 or 3 weeks in, you might be revisiting that because, actually that wasn't such a bad idea after all. And suddenly they've got a spark and they're going with it. Escape the obvious. Now, this is just a suggestion. Now, obvious subjects will be tackled by lots of teams. All right. Anything that's particularly mentioned in the game manual or the sparks, those things, there's going to be a lot of teams that do it. But if you want to be a little bit outside the box, look for something unusual. Focus on something narrow rather than being broad. All right. So start with something in a narrow area and then look at the broader application of that. Join the circus. So presentations can involve music, dance, violin playing, tap dancing, poetry, songs, gymnastics, anything that you can think of. Be impressive, passionate, and be outrageous. One year, our kids put on a magic show for the presentation. What they were looking at was how magic can help shy people overcome their anxieties. And so they put on a magic show. We've had a circus. We actually got a circus trainer actor to come in and work with the kids for a couple of sessions on how to do circus tricks, and they use that as part of their presentation. So yeah, nothing, just remember though, they only have the 5 minutes and they need to get the information across. So as much as doing a circus might be a fun thing to do, if they don't actually get the information across, then it's not really worth doing it. All right, you have 300 seconds. Don't waste one of them. All right. You want to set a scene, you want characters, you need to do that as soon as possible. You don't want to spend 3 minutes setting the scene on what's going on before actually telling the judges what the project's about, what you're looking at. All right. Even if your presentation doesn't involve a skit, you want to set the scene about what it is that you're looking at as soon as you can. You may need to go over your script and find things that you can remove, different ways to say things so that they're shorter, more succinct, more to the point, things like that. Start strong and be memorable, right? The judges are seeing other teams. You want to be the team that they remember for the presentation. You want the judges to be able to go to deliberations and talk about this team that totally wowed them and what they were doing and what their project was about. Rehearse. Make sure that the kids take the time to practice before they get to competition. It's no good the day before going, oh, well, here's our script, let's just read it. You need to be ready a couple of weeks before your competition date so that they can practice, they can be familiar with it. They're not standing there as cardboard cutout robots reading word for word off this sheet that they've only just put together last night, all right? It shows. Now, we always say that the first read through of the script should always go longer than your 5 minutes. That's a good thing. You've done a lot of research. You've got a lot to put in there, a lot to say. You will have to cut material, but it's fine, you've done good research. However, on the flip side, if your presentation only goes for a minute or two, maybe you need to do some more research. Maybe you need to iterate your design. Again, look for how you can improve on it. What have you missed? Remember, keep going back to the rubric. And the judges will ask questions. Practice them with the kids. Get random people to ask them questions. Not always the coach asking them the predictable question. Get a parent who doesn't know anything about their project to ask them questions. Get another teacher to come in and ask them about their project. They should be able to answer any question the judge throws at them. And if they can't answer the question that they're being asked, then maybe they need to go back and look at their project again and review their notes and what they're doing. Imitation is the sincerest form of flattery. So Murphy's Law for innovation projects is the closer you get to your tournament day, you are likely to actually find something that actually resembles your project being solved, or someone else, you'll hear something on the news about something's happening with this particular thing. That's okay. There'll be people who have the same idea as you. Even at the tournament, there may be another team that has the same idea as you. I remember our first international one where we were looking at diabetes, and there was at least 6 other teams at that international event that were all looking at diabetes and all looking at an app on how to manage it. And that was our project, that we thought we were the only ones in the whole wide world who had thought about this great idea. But that's okay. It doesn't matter that the judge might see 2 projects exactly the same. It's how you present it. It's the research you've done, the information, how you've shared it. It will not necessarily be identical. And understand the purpose of the innovation project is about discovery. It's about learning. Right, a good project will see your team members exploring, learning, and asking questions, and anything else they do is a bonus. Right, they may learn new skills in making a model for their innovation project. They may learn new skills in researching. They may have never spoken to a professional before, and they may learn how to do an interview and take notes. All very, very good skills for them to learn. All right, any questions on that?
No questions have come through Slack or the chat, but there was a comment from Ben Stanley that said mock judging, practicing your mock judging is a great idea.
Oh, yes, do take your kids through a session. So when we're talking about practice as well, get them to practice the full 30-minute judging session. They've got to stand there. You know, they've got to actually most likely stand up for that full 30 minutes. Some kids find that really, really hard. So what exactly do you mean by a skip for the presentation? So I'm actually got some things to show you, and this might help. I'm just going to make sure I've got sound on for this one. Share sound. All right. So this was our team's magic show. So this is a skit that they put together, but got the information out as well.
Welcome, one and all, to our magic show.
Unfortunately, the sound is not the best for this one.
A flower. Now watch this shy child become a self-confident young lady.
Is there any sound coming out?
Abracadabra.
Yeah, okay, good.
Unfortunately, that's just our roadie, and nothing's changed. Shyness and anxiety can be crippling. Even those aged over 100 still remember the pain of shyness in their youth. There isn't a magic solution. These feelings can be managed, but change won't happen overnight, and sometimes medical care is needed. Tough crowd.
So the question is, how do we improve the way shy children learn self-confidence and social skills?
We hope you ate before the show, because this isn't a simple flourish, but could take a year or more if done correctly.
Is there a psychologist who can define shyness?
The APA defines shyness as the tendency to feel awkward, worried, or tense during social encounters, especially with unfamiliar people.
Yes. Shy people tend to have negative feelings about themselves, worry about how others view them, and tend to withdraw from social interactions. Physical symptoms such as nausea and dizziness are common.
Are you turning an introvert into an extrovert?
No. Does anyone know why?
They aren't the same thing. Introverts don't mind being with people but prefer to be alone. Shy people may not want to be alone but are afraid of social encounters. This is linked to social anxiety.
Which makes this transformation very complicated.
What social anxiety?
Can you enlighten the audience?
Someone with social anxiety disorder continually fears that they will act in a way that'll be humiliating or embarrassing.
Can't you just toughen up though or grow out of it?
What is that I hear? The voice of ignorance?
Some people, given the right opportunities, can develop skills that let them cope. Others require professional help from counselors and psychologists who use many tools.
Exposure therapy, sand tray, wishbox and more.
But we have a new and different idea.
Our solution is to teach shy children self-confidence for a program called Now You See Me, which uses
magic.
Why magic?
Magic develops many skills that build self-confidence.
I know this is claimed by magic schools and those selling products, but do you have proof?
Yes. We surveyed 64 magicians and found dramatic results. One example. Before taking up the craft, 54% described themselves as shy and only 31% as confident. After learning magic, shyness more than halved, whilst confidence more than doubled.
Increased self-confidence is just one of the side effects of learning magic, just as with activities such as drama and sport. However, you only benefit if you show up. Some shy children won't.
Now You See Me is different. It focuses on the needs of shy children, progressing at their pace, with no timetables. Activities use counselling and psychology techniques. Magic sparks interest, and fun and wonder overpower their fear.
That sounds interesting. Now You See Me has 7 stages.
Step 1. Meet the child at home. Build a rapport whilst teaching simple effects that they can't fail. We discuss
With the child perceiving a threat, activating the flight or fight response. With the child perceiving a threat, activating the flight or fight response. They feel terrified. They take action and begin to feel safe. but they have not overcome their fear, and it is worse the next time.
Thank you. We break the avoidance cycle through exposure therapy. This is a psychological treatment that was developed to help people confront their fears. Our Now You See Me program takes this therapy in a brand new direction. Step 2. Form a group of 3 to 5 children. Prime numbered classes encourage working as a single group. Children show off their effects, learn new ones, and get used to performing by acting as the magician's assistant. Step 2 concludes with a show for the parents, with a mix of magician and assistant effects. Steps 3 to 7 involve learning new tricks, progression to bigger audiences, but, most importantly,
the apprentice becomes the magician.
1, 2, 3.
Unlike some magicians, we're actually willing to share the secret. Detailed instructions are in our teacher's manual.
But that's exposure. Sharing the secret spells the show.
Only for those wanting the secret. We teach the skill, building new, confident magicians.
But magic academies and training already exist. Just log on the web.
Not like this. We're combining magic, psychology, and counseling in a tested package produced for shy children by children, and can be used by professionals without the magic experience.
And implementation is cheap and easy. Step 1 is like having a tutor at home. Step 2 almost requires a neutral place such as a church or community centre. Performance spaces can range from busking to the stage. Class cost models will be similar to typical after-school activities. Now for the final effect, shyness disappears.
Abracadabra. Now You See Me is in the final stages of implementation. We have tested the magic lessons and are now awaiting ethical review from the University of Wollongong. We will then study and co-author a research paper with Dr. Gerard Stoyles. Thank you.
So that was at the World Festival in St. Louis many years ago. And so we were doing that in front of a very big crowd as an encore performance. But that is a presentation as a skit. I don't actually think we've got time to show another one. Was there any other questions about the project at all?
None that have come through.
All right. Angie, your turn.
Awesome. Can I get control again, please?
Yes. Yep. There you go.
All right. So just going to recap on the core values, what they are. So we have discovery, we have innovation, we have impact, we have inclusion, we have teamwork, and we have fun. Now, through everything that you've heard today, I'm hoping you're starting to realize that the core values really is the integral part that ties it all together. And that core values, while you don't produce a product at the end, you don't have a robot that can complete missions, you don't have a strategy, you don't have a new innovation that's going to solve an amazing world problem, you do have a whole bunch of skills that you've hopefully developed throughout the program, throughout participating, that are all linked back to the core values. So again, we also have our gracious professionalism, which is how we conduct ourselves throughout the way. You just saw that in that ProjectB, the Project Cephalus video there of their presentation. You know, they were young kids. That was a young Faith and a young Isaac there who were presenting the robots to us before. But, you know, up on a stage, being able to carry themselves in a professional manner. So also that competition, making sure that you are helping out. An example of that today is all of us being here today. Although for the majority of us, it is coaches, although I have seen a few team members here as well. That idea that we're here to help one another. At the start of the day, Andrew said that both Project Cephalus and Team Apollo, we do not have all the answers. We certainly have the answers to the problems that we have come across that we're happy to share. And if you can learn from our mistakes, that's great. You know, it's all about us working together so that we create that playing field where everybody is winning, and winning can look different from being top robot score to just learning and achieving things. So part that I wanted to have a look for now is how we go about applying those core values and what they might look like when you don't have a product to produce at the end. What does it look like in applying those core values? And some of these things are going to be fairly obvious. Some of them are going to be things that you may not have considered or thought about, especially for a young team of primary and high school age students. You might be thinking, well, you know, I didn't even think about covering this with them. So a couple of the highlights I want to just go on it is in everything that we do, and we need to build them in from the start. Gracious professionalism is that idea, as I said, about what we cover, how we act, how we portray ourselves. How you compete outweighs your robot score. If Andrew said it before, your robot fails absolutely spectacularly, what we want to see is not a team of kids who get angry, get frustrated, yell and scream and things, that they handle themselves well, that they can take, that they've learned that resilience, that they can take that loss and learn from it and think, well, what can I walk away from here now, having learned and do better next time. And it's all about how we share things, sharing things with other teams. Ideas come from everywhere. If you have an idea, don't be afraid to share how your team solved a robot mission. You'll see if you do a Google search, if you jump on YouTube, you will see hundreds of teams from around the world who are sharing how they're solving missions. Other parts of the world actually have their robot tables. They already have their field kits. And so they're already solving missions. There's no reason why you can't jump on there and be inspired. Don't copy, but be inspired and get ideas from that. And then similarly share your ideas, because you can continue to build on from there. Practice is all that we can say. In terms of core values, you know, we can teach programming, we can teach design, we can teach the concepts of innovation, but core values can't really be taught. They've just got to be practiced. They've got to be tried. You've got to just, you do have to actually just work through them to try and get them happening. And they can always be areas that you can improve. So, you know, being able to pass on skills from older team members to younger team members, or, you know, newer team members, to passing on skills throughout your experiences. So one of the first things that comes about when we're thinking about core values is, and one of the things that the teams are often judged about, is their team identity. So right at the beginning, it's a really good idea to start getting the team to think about, who are they and who do they want to be? You know, what's the team name? What is a team logo? What does it look like? What does their team want to be known for? What do they want to be strong at? Creating that team identity creates that camaraderie between them, because now they have a team that they belong to. Please don't take this as criticism. Any schools out there whose team name is simply their school name, but they feel much more like they belong to something unique, something that is their own, if they can take their own name and create their own name and their own logo. So team identity is really, really important. You know, if we were to compare it to some of the major fast food hamburger places, there is a difference. You're either a Macca's person or a Hungry Jack's person. You know, there are differences in terms of their identity and how we know them. Similarly for teams as well.
I'll just interrupt there for a second. I have seen so many kids get so excited when they get a T-shirt that has their team logo on it, and they proudly wear it at their competition. They may only ever wear the T-shirt once, but they are so excited and so proud that that's their team and their team logo on their T-shirt.
And a logo that they have designed. Like, it doesn't matter if it's not graphic design artist, you know, quality. If they've designed their logo and you can screen print, you know, you can pick up a $2 T-shirt from Kmart and iron on transfers. It doesn't have to be an expensive thing, but something that they can create and own as their own. So we touched a little bit on the concept around team roles before in the robot game. It really comes down across the whole area. So really that idea that if we take, say, a professional kitchen, for example, yes, there are a bunch of cooks in the kitchen, but each has their role. Each has their part to play to getting those meals ready and out and served to the customers. First Lego League has the same kind of concept, is that we want to create these roles, and there are no right and wrong roles. You can see Project Persepolis and Team Apollo, we do things slightly differently. There are similarities, and then there are vast differences within our team. We had for a number of years a young guy on our team who was totally not interested in robots whatsoever and did not want to look at coding whatsoever. Now you think, why did he join FLL? What he wanted to join for was the learning experiences. So we created a role for him on the team, and he was the team motivator. So he was a big guy, he was full of fun, full of life, and his role as the team motivator was that at those points where they wanted to throw the robot against the wall, at those points where they weren't finding the solutions or things that they were testing on their prototypes for their innovation weren't working, it was his job to keep the team's morale. He would come up with a game for them to have a game break, a movement break, something for them to do. He was the loudest cheerer at the robot game. He was the one that created the Team Apollo chant to help, bring on that camaraderie. So there was a role for him to play that was really, really important. Did it mean that the robot got built? Do you know what? While he didn't touch the robot, it did mean that the robot got built because he kept the team morale together. So finding what works for your team. In Team Apollo, we have a team coordinator, and they are kind of like the team leader. I guess you would think of them maybe as the team captain. And we then diversify into two sub-teams, an innovation sub-team and a robot sub-team. Within both of those teams, each team member has a role to play. So within the robot team, they will be either a strategist, a programmer, a tinkerer, a robot analysis. Within the innovation sub-team, they might be a researcher, a lead researcher. They might be an Imagineer. So they have this idea that Imagineers are the people that design and create the innovation. They might be what one of them affectionately calls themselves the crash test dummy. They are the person who tests the innovation, sees how it works, sees what works with it. They might be the PR person or the HR person who is the confident one to contact these professionals, make that first point of contact to reach out and say, hey, we'd like to meet with you. This is what we're doing. So everyone can have a different role. It really is important. Just having everybody doing everything is not how effective teams work. You don't have everyone in a soccer team all doing the same thing. Okay, everyone diversifies. You all come together for a common goal, but you don't all have the same role. So if I can encourage nothing else but to help your team find the right roles, and there isn't any right or wrong roles, it's just finding the right roles for your team. This comes down to looking at your team dynamics. So, without going too in depth, it's almost like doing a bit of a SWOT analysis. So looking at each team member's strengths and their weaknesses. What do they bring to the team? What skills do they already have? And what are they eager to learn? Knowing that the team really stands for together, everyone achieves more. So that idea that we achieve more when we work together than when we're apart, or two heads are better than one. So looking at how your team structure comes together. Some people, and certainly within Team Apollo, we have seen this over the years, you can be best of friends, but you do not make good working teammates because you don't necessarily work well together. You don't get things done, whether it's because you're too busy goofing off, or it's, what you have in common is not what you need to achieve and the goals you need to reach. So helping you look at what your team dynamics are. And this all comes down to to core values of teamwork and inclusion. How do we include everyone? How do we make sure everybody has a role? And it also ensures that if you are doing something that either is your strength or is an area of interest that you want to grow in, you've got your discovery, and you are ensuring that together you're working together as a team. It's definitely going to be more fun. For each team, it's really important that you set your team goals. So there are the obvious goals. Get as most points as you can on the robot game table. Do really, really well in the innovation project. If you're lucky and you're one of the few, walk away from a competition with a yellow piece of plastic, the Lego trophies. They are obvious team goals, but what is your team goal this year? So, for example, Team Apollo set their goal a few years ago that they wanted to make sure that in their robot game, that when they were going out and doing their robot runs, that they were able to complete multiple tasks simultaneously. Now, that was a work in progress where that year they got in one run, they got 2 missions being completed at the same time. Over the time, they've expanded on that. Last year, their goal was for team members who had been coding for a little while to actually transition and be able to learn to code in Python. So that was a goal for them, but they still kept the word blocks for the younger and newer team members. So setting team goals, what do you actually want to achieve? What is it? What are those skills that you're going to discover this year? Does it matter for the competition whether they coded in Python or word blocks? It actually doesn't. In the interview, the judges do not score you higher because you coded in Python. Do they score you higher because you acknowledged it as a goal and you set about making sure that there are ways you could achieve that goal? Absolutely, most definitely. The thing with goals, though, is that there's that idea that we need to make smart goals. Goals should be very specific. We should have a way that we can measure them, achievable, realistic, and timely. I'm sure all of you that work in any kind of, or ever have worked in any kind of professional team, this is not something new, but they're things that we maybe don't think about sharing with a group of kids. So when we're asking them to set a team goal, if they're going to be big, broad goals, like we want to get 800 points on the robot table, I don't even know if that's feasible this year, but we want to get this. Okay, how do we break that down? What does that actually look like? What is that goal? What do we need to do? What are the smaller steps before that big goal is achieved? And so getting them to start to think about that, because what happens is at the end of the season, you actually see how much you won by achieving those goals. Did you win yellow piece of plastic? Maybe, maybe not. Did you win because you achieved all those goals? Absolutely, most definitely. One of the things that is often overlooked by young people and older people as well is around time management. And I think that this is one of the areas as coaches we have probably the biggest play for them. Some teams are limited to, we get to practice during our lunch break 3 days a week, or we get 2 hours after school on a Friday. That's their limitations. But make the most of the time. Spend some time helping your team make the most of what they need to do. What can they get done in the time when they're together? What can they get done in the time while they're apart? If I can, actually, I don't think it's going to work. No, it's not going to work because I'm going to back the thing. On my whiteboard behind me, my team met yesterday, and they've put this big, massive whiteboard full of, they broke down each of their roles and all the tasks that they felt that they needed to cover and get done. And then they started breaking those off and having a look at what needs to be done now, what's a weekly task to be done, and what are tasks that, so breaking those into a timeline of how to achieve those. So they're starting to make those planning ideas to get to that end result of a robot that achieves well, is built well, and is innovative, a project that is, solves a problem, is innovative, and that is, has a real world impact. Always in a core value interview or core value section, teams will be asked about something along the lines of how did they go about making decisions, or how did they resolve problems as they came up. Up until a couple of years ago, there was a core value interview, and during that interview, teams had to complete a core value activity. So that was everything from, build a tower out of spaghetti and marshmallows, decide on which, out of a list of 10 items, which of them would you take into outer space and why. And basically the team worked through the exercise in front of the judges, so that the judges could see the team actually putting into practice the core values that they were being assessed on. One of the things that is the biggest driving force here is about how the team makes decisions. Some teams make decisions purely by the loudest, most boisterous person in the room. Their decision goes. Some teams make decisions poorly by it being the coach or the teacher who makes the decision. In order for our kids to learn, they need to make the decisions and they need to make the mistakes. We might foresee it and be able to think, oh my gosh, that is never going to work, but they aren't going to learn that unless they try it. So different ways of making decisions. There could be some teams opt to put things to a vote. I've seen teams who, when there's a decision to make, they flip a coin or do rock, paper, scissors. Some teams, discuss it out until it becomes to a consensus. So there isn't one right or wrong way, but having a way that your team makes those decisions. And I guess what that actually touches on, is what we might think of as team rules or team processes. What needs to be done? How does your team make the decisions, and how do they make sure that everything is being done? So having a set of team rules or team processes, just like all of you, I'm sure, would have in your workplace, when there's a decision to be made, how does that get done? If it impacts multiple departments, multiple year levels for our teachers, how do you decide who makes that decision? Maybe for Team Apollo, if it's a decision and it's being tossed up between multiple people, the head of that sub-team will have a final extra say in what way the team goes. Sometimes it's wrong and they realize that, and then we can always backtrack and go the other way. But making sure that you actually have a process, and there's not a right way, it's just making sure that your team have a process, so that when the judges ask them, how did you decide, how did you make decisions in your team? They've got a way of asking you. They've got a way of answering that. And this obviously leads us to conflict resolution. Teams will have disagreements. Teams will not always agree. If they are someone who has been drawn to the program, then they are going to be innovative, creative, out of the box thinkers. And the problem with being out of the box is that you don't all think the same. And so you are going to have conflict, but how do you resolve that conflict? Again, is it a case of, sometimes it's the coach who says, there's usually a question about in the judging session that's about how did what kinds of problems did you come up against and how did you resolve them? When teams say in a judging session, we didn't really have any problems, that's usually a dead giveaway of one of two situations. Either A, the team's outright lying to us in the judging room, or B, the coach or teacher or mentor has actually delegated and decided everything for the team. Because when the coach delegates everything for the team, then there is no argument or kickback. They're not going to argue with each other because the person directing them, in which case we don't want that. We want to see that they do have conflict, that they have difference of opinion. Personally, if my team do not argue about big wheels or small wheels for this year, I would be grateful. But they're going to have ways of deciding those things. And how does your team resolve those conflicts? What are the results? The last thing you want to see is team members leave a team because you can't resolve a conflict. So making sure that they have processes in place, and that comes back to that original team goal setting. What are the policies, what are the procedures that your team are going to agree on? They need to agree on those in a calm moment, not in the middle of a conflict. Coming up with an idea of how they're going to resolve those. As I said before, these are all areas, you think, well, where does that actually fit into in the core values? Well, it's all about that teamwork. It's all about that inclusion, and it's all about that discovery. We are trying to teach these skills that these guys will take on into any area or any workforce that they may go into outside of school. The knowledge base they will develop, but these are skills that they need to just practice and experience to really actually learn. One of the biggest, most popular areas, or often overlooked at the First LEGO League challenge area, or First LEGO League section of First, but is all about outreach. It's about connecting with other teams. It's about finding other teams that you can work with, that you can share with, that you can make connections with. Perhaps you will go in and teach them something, or they'll teach you something. Perhaps it's just about sharing and practicing. Team Apollo makes a point of trying to visit a number of different teams over the season so that we can practice. We talked about mock interviews and mock judging. We'll set up opportunities where some of the other team members will, other teams will ask my team questions and vice versa, so that they can have a practice and see where the gaps and the loopholes are. It's not about putting on a show. It's not about being perfect at something and going and demonstrating their perfectness, but it's about sharing that knowledge and learning from each other. The other thing about outreach is it's about sharing the experience. All those skills that your teams have learnt can be then shared with a lot of other groups. Team Apollo does a lot of work with disadvantaged and disability groups, and I'm really, really proud of that kind of work that they do, that they get these guys. So we have seen just in this last week, we were working with a young guy who has quite restricted speech, and he was super, super excited that, he was a 17-year-old who was working with a WeDo set, but he was super, super excited getting his robot to say up and down, and that was just working with one of the groups that we work with. But it was practicing his speech and practicing a skill that he struggles with, simply by us sharing the experience of robots and coding and sharing all those sorts of joys and things like that. So outreach is a really big area and a really strong area. I'll be the first one to put up my hand and say we will travel, and we also welcome teams to come to the Central Coast, and I know Project Bucephalus are much the same. They will travel, and they also welcome people to join them in Wollongong. So if you're looking for outreach, please reach out. And of course, we've all learned the wonderful skill of Zoom, so we can always outreach over Zoom if you like. That's always an option. And I'll also shout out to Ben Stanley's team. Is that one of I think it was my team's second year, and I think it might have been their first year. One of the outreaches that we did do was attend a Lego festival, demonstrating what First Lego League was. And from that, and that was here on the Central Coast, and from that, there were 4 new teams that were formed that joined the First Lego League program just from us being there. But it was also an opportunity. Ben's team were very strong in robots, and that wasn't such a strong suit for Team Apollo, but where we were stronger in the core values and the project, and we were able to share with their teams how we do things so that they could learn and we could learn lots from them. So outreach is a requirement of the FTC and FRC programs within First, but it doesn't mean it doesn't have a place within the First Lego League program. And in terms of core values, practice makes perfect. So I said before that originally in the core values interview section, there would be a core values activity. They don't have that anymore, but that doesn't mean you can't do them at home. I mentioned earlier, Team Apollo tend to play more games than sometimes I think that they are actually working towards their innovation or their robot, but practicing, whether it be truss falling, getting through spiders' webs, getting themselves out of knots, tail flipping. There are a range of, you Google search, team building games, team building activities. They take 5 minutes out of your time. Maybe it's a movement break. Maybe it's how you start your day, you end your day. But practicing those skills and getting them to look at how do they communicate? How well do they work together? Do they listen to one another? Do they agree? What do they do when they don't agree? So giving them plenty of opportunity to practice those skills in a fun way before it's actually needed to be implemented in decision-making around the robot, the innovation. Okay, look at that. I got us back on time, guys.
Yay.
Before were there any specific questions about core values before we move into the full questions and answers?
Not that I can see. Just Ben had commented that one way to make sure the team project and core values is presented by the team. Ceremony of the gaff tape where all the coaches and parents have to keep their mouth shut so they don't get in the way of the team.
Yeah, definitely. Yeah, awarding them their gaff tape for the event.
So if nobody has any big questions, we do have the full run from last year's robot, the Bucephalus robot, we can show you. We also have another example of a project presentation. But please go ahead and ask questions. This will be put up on YouTube afterwards, and I'm like 100% certain there will be others that will be thinking as well. Also, if a lot of this stuff was over your head, that's okay. You can come back here and use this as a reference. We've both been doing this for a very, very long time. So you take what you can and you use it as a basis. So if any of the teams have any questions or coaches.
So I think Ben Stanley's group, they are all waving their arms around. So if you want to unmute yourself to ask the question, please go ahead. Or will there be a way to access the slideshow?
Yep, I will put on the PB website, I will put up the PDF export of all this stuff, as well as a link to the YouTube.
So anyone from North Brisbane area, Michael would like to collaborate. You probably, Michael, if you're on the Slack, I think you might be on there now. That's definitely a larger resource of coaches around to collaborate with. Just post a question out there and
I know like both Apollo and Bucephalus are pretty good at collaborating on Zoom. So if you want to spend some time chatting, your kids talking to our kids, that can definitely happen.
Are Lauren and Lisa still on, or have they left already?
I think they've gone.
They've gone, okay.
Yeah. So yeah, bear in mind, guys, this was a drink from the fire hose type of situation. It took us, well, it probably took us 4 to 5 years to get to the point where we could act on this level. And we did some fairly major stuff ups along the way.
Our robot in Canada.
Yeah. Like our third year, we decided we wanted to try some of those really big attachments. Our robot didn't move for the first 20 seconds of the first match at the regional. And we had a whole bunch of teams come to watch us because we were Bucephalus. We had a really big robot. That was not a fun experience. But it did form a lot of why our team does things the way it does. So there's one good thing about having history you can pass on, is people remember those lessons. Okay, well, while you're thinking, I will share.
Hang on, Angie had something to say.
Yeah,
I was just going to add on to that. I think, I am still constantly wowed by Project Bucephalus's innovations and their robots. And, I know our team do well, but we do things differently, and that's okay. But if you take anything away from today, it's that there isn't a right and a wrong way, but use that KISS principle of keep it simple. And keep in mind that joke about the astronauts trying to work out how to design a pen that could write in space in 0 gravity, and the Russians brought a pencil. It is perfectly okay to bring a pencil. Okay, it is perfectly okay to have a pencil in this competition. You do not need to have a pen that can write in 0 gravity. Great fun, but you don't have to.
I do have to point out, if you talk to a NASA person about that joke, they hit the roof. Graphite from a lead pencil in an enclosed space station is a fire hazard. So yes. Okay, I will run this video, and if you got any questions, please go ahead. I can also pause it at any point if you want to ask any questions. Okay.
Do you want me to stop my share, Andrew?
Yeah, stop your share. I'll do that again. Share the screen. Right. So bear in mind, this is being done as a class 4 robot, which was a deliberate choice by the kids when they started. They also set the goal of, we want to do every mission on the field. Now that is probably going to be overreach for a rookie team. Although looking at how the boards are being arranged this year, it's possible you could make an attempt at every mission, just not do everything on the board.
So Andrew, before you start, there's a question about attachments. Are these from an additional kit that we need to buy? So how do you build your main robot and then have all your attachments? And looking at that, we've got a lot of Lego there.
Yep. So basically, you're not limited to a single kit. If you can get Lego pieces from anywhere, if we're buying stuff, we'll typically buy it from Bricklink, or we'll go to First Australia and buy some past field kits. They usually have a backlog of those. As you can see, the parts on the field, there are a lot of really useful things for building robots.
Also asking if there's anyone who has old Technic pieces that they don't want anymore.
We got Technic pieces that belong to my uncle when he was like 10, I think. So they're probably older than my son, let the truth be told. But they still work. So the design is all your own. So check this out. Let me know if you can't hear it.
3, 2, 1, Lego.
So if you have a look, we got a pneumatic switch on the side that hit the turbine holder and activated the pneumatic motor. As the switch comes down, you fire the cannon. And again, pneumatics are being used to grip the containers. You get points for the orange one going up and down. You leave the chicken in the container back in a circle. And when you touch it, runs back and back. Knock the blue box out. You're going to pull the orange plane down, push the orange one on the right, push the green box into the circle, push the engine, push the green box back into a circle, and then get back in the home. Now that plane, the orange plane, had to end up on the other side of the robot. So rather than flip it over, we're putting it on a little cart and having it roll out. That white box that we've got that blue thing in, that's our innovation project, the Kid Project Bridge. There we go. So the innovation project is actually useful. Cool. So there goes the bridge. That comes out, there comes the blue box from the helicopter. Push the train down. Now they made a strategic decision to grab the robot there because they didn't want to waste time coming back to base. And the kids have got the horse mascot on the robot. That's been a feature for a very long time. We've got to deliver those grey boxes to the ship. We've got a little bit wonky there, so we're not quite straight, so we're only going to get one of them. So I push the crane. You can square up on the wall. And hit the orange and whack the truck. And I think we had like a second to spare on that one. So any questions on that?
Is the robot just using color and light sensor?
Now it's using the internal gyro as well as 2 color sensors. So elastic bands, pneumatics, gravity, alternate power sources are really good things to look at. So the reason we were able to do so much in that first mission was because of the pneumatics. Okay, so I'll stop sharing.
Now, well, I guess one thing people should know about our team too is it hasn't been the same kids every year. We've had a different bunch of kids, some aging out, some not coming back, new rookies coming in. So it hasn't been a constant, X number of years. From the time Faith joined the team when she was able to her last season last year, there was a couple of years where we had a completely new team. She was the only one who was from the previous season. Things like that. So they can still, we've had years where we've had more rookies than we've had veterans. It's still possible to do it with a rookie team and do well.
We also have big age ranges. So we will always have someone on the upper age range, like a 16-year-old, and we'll have an 8 or a 9-year-old.
What is the ideal number per team?
So I'm going to answer that one with how long is a piece of string? It works both ways. So if you have a small team, say 2 to 4 kids, it's really easy to manage them and keep them on task, but there is a lot more work per child to do well. The personality conflicts, about can be the same. You get a big team, you got to herd cats, but you also have the opportunity to divide and conquer. I can have, with Bucephalus, we can have 4, 5, 6 of the kids out working on the project, and the rest are doing the robot, and they'll swap out as they need to as tasks become available. So it works either way. Probably the average team number would be about 6 or 7. That tends to work okay. It does also come down to the number of adults you have available. Sorry, I can't do a better answer than that.
Passive attachments are, I just lost that.
So passive is good. I can actually I'll show you another example of using passive. Bear with me a second, and then I'll answer Shannon's next question. Hold on a second. City Shaper is a good example of that one. So when I said when we were deciding how to do missions, the whole doing it without a motor, that makes a huge difference. So if I come in here, we go. So this is our City Shaper robot, same style of class 4.
3, 2, 1, Lego.
So that whole black thing is a passive guide for the blue box to come down. The next one has got a bunch of non-powered motors. If you ever look at a non-powered attachment. So here we go, we're pushing stuff along into the field. Everything's designed to come on and off really fast. We had a bit of a fumble on this one, but you got there. Now see those claws out the side? Those are designed to lift the traffic jam. So watch what happens when we drive past it. So just lift it up and out of the way. Now this elastic band catch we've got on the front, no motors, but it flicks the wheelchair out of the way. Square up on the wall. This is the only powered attachment on this whole run. That little arm. It's going to knock out 4 of the 6 posts holding up that building, and you keep all the point. You get points for every post that goes out. Now we just gun it back to those. So yeah, passive attachments, things that can operate without a motor, is particularly useful. Yeah, there are also, if you have a look, I think they're called clutch gears. They're gears that move for a while, and then when they hit a limit, the insides keep moving, but the outsides don't. There are several techniques for building one-way latches too. So something will turn one way, but it can't turn the other way. A whole bunch of mechanical tricks that you can find. Again, if anyone wants to go through that stuff with us, we're more than happy to do a crash course with some of your teams.
So do you have them working together the entire season as one, or pre-season as well?
Well, we have fun with that because we have this tendency to get picked for international events, and they often don't run until June or July. We finish just enough time to start the next season. So in effect, we work with them. We start working with the kids maybe a week or 2 before the season starts, but in practice, we've got them coming for most of the year. We do take a big break around FRC season. As it turns out, probably about half the kids in the team are FRC students as well. So yeah, 5985 is the Bucephalus FRC team, and it's got a really, really big involvement of Lego robotics nerds. So we do a lot with that.
And Team Apollo would be pretty much the same. We are meeting all year round purely because the start of one season and the end of the previous are very close together.
Yeah, I think this year we only had 4 weeks off.
Yeah. I will offer one word of warning to anyone that thinks, oh, the international thing is not something I have to worry about. I have seen more than one coach have near heart attacks when they figured out, oh, you've just got offered a spot to go to Russia or South Africa or Brazil, or you don't necessarily have to, you don't plan to do it, but you should have at least some preparation. Anyone else got any questions? Okay, well, while we're waiting, so how far did we get over what an in-person competition is going to be like? Did we just cover the robot game?
We've talked about all sorts of things. We did talk about 3 robot games that go for their half-hour judging session in the morning.
Yep.
And then they'd be a bit slower on the robot games in the morning, but then in the afternoon things go a lot faster. So
when you go to an in-person event, expect to arrive early, usually around 7 o'clock, 8 o'clock, if it's a non-school one. There'll be a coaches meeting, which you really, really have to attend. Get the kids managed by a parent or something. There'll be a lot of information there. And then you'll be given your schedule and go. Now, there's a couple of etiquette things that you really need to know. The first is with the practice tables. You should only ever have 2 bookings live at any one time. So if you go out and start booking slabs, where's it? You get 10 minutes at the table these days?
Something like that.
10-minute slot. So you can book. You can't book them back to back, and you can only have 2 active at any one time. One of the best ways to get everybody really mad at you is to try and book huge slabs of time on the table. So don't do that.
So that is providing there is practice tables at your event, because there may not be. The practice tables used to be supplied, but now it'll be a case of the regional partner asking if anyone is willing to bring their table for practice. You might need to bring any loose elements that your team is likely to use, like your energy cells or things like that, to the event if you're going to be using those things. And yes, there will be practice tables at the Wollongong event.
Yeah. Now, one of the things we do to get around that, because there's often teams in utter panic, we actually share practice table. Our record is 3 robots running separate missions on the same table. So often when we go to a table, we're only interested in running one particular mission on one particular part of the board. So if we look at another team that's having issues, we'll say, hey, come up and join us on our slot. You keep up that end, we'll keep up this end, and just keep going. So I said a record is 3 teams going at once. So that type of thing helps a lot. When you get to the rest of the day, make sure you are queued up for your robot game ahead of time. Gives you an excuse to do the dance, laugh, and also get everybody to deal with nerves, because most of the mistakes you'll get from humans are from the kids being overwrought or overexcited. So spending some time getting them calm beforehand and focused is always worthwhile.
One thing I forgot to mention, I think all of us forgot to mention, is have checklists of what they need to take to their judging session.
Yes.
I never forget. We got all the way in Legoland, California, and between where the pits were and the judging was a good 10 to 15 minutes walk. We did our project judging and came out, and we were about to go in for our robot, and it's like, where's the robot? No one had brought the robot down because we had so much other stuff. It's like, make sure you have your checklist to make sure you're going to take your robot, you're going to take your attachments, you're going to take your posters or your documentation, you need the white hat with the flower on it, or whatever it is. Make sure that the kids put a list together and have someone in charge of making sure you've got everything before you go off to your judging session.
Yeah.
And going to your tournament.
Yes.
Things that I've heard, and they're like, we left the computer that has the code on it at the school and we can't access it, or we left the thing that we needed. So checklist for packing to go and checklist.
Yes. I think it was the Lost Girls came to a national event and they'd left the whole attachment back at home, but because they had photos and we had our robot first aid station, they were able to build something very close to what they needed.
So bring food, bring sugar, spend the time getting to meet other teams. Go over and say, tell us about your project, show us your robot, compare notes. It's a really good way to figure out other stuff. I mean, Isaac was notorious for going to test the robot and ending up with about 40 people trying to watch the robot and then giving an impromptu lecture on how to design robots. We had to pull him away from those a couple of times. Also, little things you can do, like we were talking about the team uniforms. A lot of people like to try and personalize what the kids are wearing. That gets expensive. So what we do is we do name tags. And I'll turn does that focus on that?
No.
I'll turn the blur off. So we go into the local print shop and order. We'll hop onto, I think it's Minimizer is the name of the application. And each kid designs a Lego minifigure version of themselves, which then goes onto a badge that they wear, or even as a button badge. We used to have those on the shirts, but then it got a bit too expensive. But something like this is only a couple of dollars per name tag. And it's a good way for the kids to represent themselves. Some teams will even make minifigures. They'll go on a BrickLink, and order custom parts to make themselves as a minifigure and wear it as a badge. So there's a lot of cool stuff like that you can do.
All right. So Andrew, there was some
Containers.
questions about looking at more passive attachments.
If anyone's
mechanisms.
interested in seeing a mini workshop on passive attachments, we can arrange that. So put a message on the kickoff channel, register your interest, and we'll organize something once we've got the fields and tables set up.
One thing at an in-person event happens probably more at a national and definitely at international events, where teams might share, they might do button badges or stickers or things like that they will go around and share with other teams. It's a great way for kids to go up to another kid and say, hey, would you like our button badge or our sticker, and you know, do you have one, and they'll share and things like that. So there was a question about containers and storage.
You got some of the boxes behind you, don't you, Linda?
Yeah, I do. You have.
You go, I've got your
While
spotlight.
she's getting them, Kmart is your friend.
Bunnings.
Yep.
This is our peg box. This is just full of pegs.
Don't hold it up. You know you're gonna.
No, I won't hold it up, but it's just got little compartments that the kids can pull out from the box if they need to. That's one of ours. We also
So our approach is we use those trays for storing little stuff, those trays for storing beams by size, and then we use old ice cream containers to store everything else.
our overflow container.
Yeah.
This is the 11 beam overflow container, which is feeling rather full at the moment.
So you can we buy those trays we normally take to competitions with us. The ice cream containers typically don't.
So they were just from Bunnings.
Kmart is also a good one.
That's the next question.
Question here about Chromebook, Windows and iPads in terms of preference. With an iPad, the issue you have is that you must Bluetooth for your robot. Now, if you have one robot in the room, it's not as big an issue, but if there are multiple robots in the room, if you are running it through a class activity, connectivity to multiple robots, particularly the Spike Primes, EV3s you can name and it keeps its name. Spike Primes like to return their name to their default Lego serial number every now and then, and they're all called toy something, 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 something. So I would always opt
when
for,
they update.
yeah. Or I would always opt for a PC over, over an iPad. But if iPads are what you got, they can work. Chromebooks, my understanding is limited issues.
It was issues.
Yeah.
Issues. They lost their code. Like,
I think limits. You have limited abilities. You don't have all the features, I believe, with Chromebooks.
The other thing with using a PC laptop versus the iPad is being able to save it in multiple locations, putting it on a USB. It's not restricted to just that particular iPad. And if you've got kids working on different projects, it's easier to bring it all together in one place on a PC or laptop.
The other thing, Team Apollo have experienced before is that, they might only be running with one robot, but they Bluetooth, download a program via Bluetooth, and it just doesn't seem to work. I mean, you see it download, you see it's supposed to be there, but it doesn't seem to work, and then you connect it with a cable and it works. So it can be glitchy if you're relying on Bluetooth.
Same screen size.
Dealer's choice. At least 13. So we prefer at least 13 inches for the Spike, preferably 15, I think, isn't it? We go for?
Yeah.
Yeah.
Particularly if they get into deep level coding and have a lot there.
Big programs benefit from a bigger screen.
Yeah. Is the expansion kits worth it, or is it cheaper to buy something else? So the expansion packs with Spike now come with a motor and an extra color sensor. For that, if you've got nothing else and you're starting out, fantastic. Now, I don't know, we usually buy our stuff through MTA. Their expansion kits are still on order. Still waiting.
Both Moore and MTA, September 19 is when they're due in.
Yeah, so if you're hanging out for that,
I actually think, if you got nothing else, an expansion kit is good. But honestly, the cheapest way to get more pieces is to go buy an old field kit and then get whatever you don't have on Brickleg. Like specifically target the pieces you want. And like getting 1,000 black pegs is like pretty cheap. So yeah, have a look. I highly recommend having a look on Bricklink. Oh, there was one other thing too. I don't know whether we're special on this one. I assume we're not, but we get the vast majority of our kids, well, they call themselves quirky. So we got kids on the spectrum. We got kids that have got certain physical, emotional, or mental challenges. I strongly, strongly suggest you put together, when you get to a tournament, put together some kind of letter or brief, hello, this is message. So you can email that to the tournament director beforehand, so they can then pass that to the judges your team is going to see, so they know what to expect. Now, the judges are pretty cool. They'll pick up on that pretty quickly, but if they know in advance, they can work within those bounds. Like we've got a couple of kids on the spectrum that cannot handle changes to the judging routine. So there was one time we had the judges had to flip part of that because something had gone wrong, and the kids nearly had a meltdown. So if they know that in advance, that's a really good thing. So bear that in mind. Again, if you're concerned about that, drop us an email. We can show you the basic template we use. And if you come into Wollongong, just let us know. We'll be able to sort it out for you.
Right, so Ben Stanley has said having multiple devices, having a network drive to save programs on makes life a lot easier, removes the dependency for a particular child to use a particular computer.
Yes, it also makes syncing computers a lot easier. Okay, I thought I got one more video to show then. So those of you that were interested in passive, this is this is our food factor robot. It was our third robot. So I'm going to run it without sound. It's actually got some nice passive things that actually fit reasonably well with this year. So this was our class 3. So knock the ball, try and square up on the line, karate chop the bridge, the truck, but we missed that. Right, now have a look. This claw, we got a yellow truck. Surprisingly like the truck we have now. That truck had to come back to base, but because it had the 4 tires on the ground, it was really, really hard to turn. So our kids went in with this claw, elastic band claw, just to snag it and bring it back. So the claw itself had no real lifting power. It was just about the elastic band to keep it on. Now here's a passive attachment. So this particular mission required us to dump a load of food on the kitchen table. Now you see this claw thing up the top? That was built into the attachment. And when it came down the other side, it pushed the oven timer on the far side. So watch what happens. Now you can leave attachments behind. So this is, again, a passive attachment that a few of the kids that have seen this have started thinking, oh, that might actually be useful. So this is why we say class 3s are also a bit of a problem. The changeover time can be horrendous. Right, this thing out the front, that's full of Lego bacteria and Lego viruses, and they have to end up in the sink. You've got to wash your hands. So watch how we deliver them. See, we hit that and that just pushes back and it all dumps straight out. So if you've got to deliver something into a bucket or a container of some kind, I'll step back a little bit so you can see that. That's it going in. Watch what happened when it hits the sink. Now, these are very small objects, so we didn't have to open it very much at all. But it's quite a useful thing. Now, also up on top, you see this elastic band over the top here? This is also a passive attachment in the sense of it doesn't need a motor, but it's actually pretty violent in what it does. So we've got a catcher to catch more of the bacteria. This year was particularly cruel. There were like 20 of these things on each one of these tippers. You got points for every one that every tipper you activated, but you lost points if there was bacteria on the ground when you were done. So you had to try and catch them all. Right, now see down here, we have a thermostat with the lever on high. So we turn that and the temperature goes down. This here is another rubber band catch, like what we used on the wheelchair swing. When this makes contact with this, it's pushed back and this flips up. So watch what happens. So I'll go back and look at that again. This bar here pushes back and releases what's holding this down. This just naturally flicks up because it's under tension from the elastic band. And again, lining up on the wall, catching more bacteria, squaring up on the line and gunning it back into the wall. That year you had to finish against the wall for bonus points. Okay, so stuff like that is always useful. Get your kids educated on what a simple machine is, and there is a lot you can do for the passive motors. Passive missions, sorry. Okay, so I believe that's it. We're done time.
Yep.
Anyone got any last minute questions, comments, feedback? Anything on Slack?
No, just quite a few people wanting to do passive attachments.
Okay, we can do that too. So,
but not today.
For everybody, do bear in mind, as rookies, you are not expected to do all of this. Pick and choose what you want to do and focus on the learning, but some of the stuff you can pick up, like the how to design a robot steps, all that type of stuff is really useful to keep everybody going. So if anyone is having any troubles at all during the season, drop us an email, say we need help, please. More than happy to help out wherever's needed.
Andrew, I don't think we've seen the resources page.
Oh, I haven't seen the resources page. Do that. Sorry, I forgot about that one. Can you bring it up?
Hang on.
That's an interesting thought, Shannon. Do a mid-season check-in with everybody. Probably not a bad idea, actually. Might save some stress levels.
Share. This one. Share. All right. Resources. So the Slack workspace, the engineering notebooks and team meeting guides that are accessed by your First Australia dashboard. There is QR codes on the pages of the robot game, which take you to lots and lots of resources that First has put together. There is the Australian FLL help desk. So there is a Google question and answer forum. You can talk to coaches, ask questions, get advice.
Now, hang on, back up, Lyndall. So the help desk is in the process of being replaced by the Slack workspace. So try and get on the Slack if you can. If you're having troubles, let us know and we'll put invites out.
There is something called Jack's Judgments. Now, Jack Arcus used to be the Australian head ref. Fred took over a couple of years ago where Jack had some ill health, but we still call it Jack's Judgments because it made sense. So that is where official ruling clarifications will be put for Australian teams. And you can make requests via the help desk or to us directly if you want to rule clarification.
What happens with that? If you want to get you can request a robot game ruling on Slack, but it does have a tendency to be open. So you could contact us or Fred directly if you don't want to share your idea. Right, and that's perfectly all right. You may not want to make your idea public. And ask, is it possible for me to do this? And you'll get a response. Also on Jack's Judgments, if you just go to the website and look under resources, there's also the links to the updates for this year as well, the official first updates. So if you want to take a look at a few of those, that's probably a good idea. Check it regularly.
There are some Facebook groups. There's the First Lego League Australia Facebook page, and there are other groups. Like I think we mentioned earlier, someone had been on Share and Learn. They are predominantly American based, and some of their things may not necessarily apply to Australia.
Yeah. Also, they are not an official group. They're quite well regarded, but they don't make decisions. So official stuff will come out of the First Lego League Australia page and the Jack's Judgments page. Anything else, basically take with a grain of salt. Just be aware it may not apply to us or the first Lego League website itself.
Best teaching resource books.
Share and Learn's got some pretty good tutorials. I mean, are you talking Spike or EV3?
Spike. So Spike within itself has several units.
There's some pretty good tutorials on board, yeah.
And they also will have, with an update, I'm not sure if it's already happened or not, but they will have a guided mission for the table, which will take you up to do the hand mission, and that can help you get on its way. And email address you can use for help is you can use the coach one if you coach at ProjectB, where you got the Zoom link sent out to you. That email will go directly to us, and you can also reach out to all three of us on Slack. We're all there, yeah. And we are active.
On that too, bear in mind, if you do ask us questions, we're pretty good at answering them, but our answers are not official. Fred is the only one that can make official calls in Australia. So if you don't like what we're saying or disagree, feel free, take it to Fred and get an official ruling. So yeah, Fred is several levels above our pay grade.
And just to point out that Melinda Blake is the judge advisor, head judge for Australia as well. So
yes,
Fred makes all decisions on robot game. Mel makes all decisions on judging elements.
Yes. So if you have a question about your project, you can send that to her. If you have a question about how they're going to present it or what they're going to do or how the judging works, anything like that, Mel is the person to go to.
All righty. Oh, yeah. So someone said the fast changes on the robot. Yeah, that comes down to practice. The kids practiced and practiced and practiced against the clock to make sure they could do it.
Oh, yeah. The first time out, our kids run the robot, we don't get everything that they've planned the robot to do done on that first run. We might get halfway through or maybe 3/4 if they're lucky, because they haven't worked out how they've got to do their changeover. I think Spake may have said something or talked about choreographing the robot changeovers. Who's doing what? Particularly if you're swapping in and out your robot technicians, you want to know who's going to be pressing the button to go to the next code, who's going to be taking something off, who's putting it on, what hand it's in, what it needs to have, what's my job, and I've got to put I've got to get the bit for the plane, and then I've got to flip the plane upside down and sit it in and make sure the latch is removed while the other person's doing all the other stuff.
I'd have to also add there that it's one area where if you've worked on your core values, you'll be fine, because they get pretty close and personal in some of those robot changes. Arms in, pressing buttons, putting things on. They can be pretty intertwined and pretty into each other's personal space.
Yeah. And we'll normally film them and then let them look at the video so they can look at where things are going wrong. So, yeah.
And, I remember years ago, Sarah Heimlich would say when she was coaching a team, when they would practice, they would then add the music. The louder the music was, the faster the kids would move, and that sort of helped them get over the line, because there will be loud music at a competition. There will be music going while they're running their robot game. It's not a nice, quiet, silent area where they can just totally focus. So getting them used to having a bit of music playing while they're running their robot and noise and the rest of the team cheering and things like that is really good for the robot runners as well to get used to, so it doesn't, so they don't get put off at competition.
Awesome.
Oh, one other thing Isaac did ask me to mention, he didn't get to mention in the session he did, was how do you disagree or what happens if you disagree with the ref at the table with what they scored you?
So what happens? Your kids, not the coach, as we mentioned before, go up and say, hey, ref, I don't think that's right. And they say why. So if they've got a copy of the rules with them, they can look, say, I think that's wrong. This is what the rule says. As long as they're respectful, there won't be an issue. Now, if the ref can't solve that immediately, he'll call over the head ref and the head ref will deal with it while the table moves on to the next game. Now, at some point, the ref is going to make a call and say, this is the way it is. Most of the time, they'll try and work with the team. But once the head ref makes the call, that's it. You sign on the score sheet and that's it.
Yeah, once you've signed, that's it.
Yeah, so they should not sign unless they're happy with the result or they're happy that there's nothing going to change. Now, one thing that's really important, there are no video replays. Do not go to the ref and say, here, look at this camera. That's not how it works. You do that once, you open a huge can of worms. So it's between the ref and the kids. And basically, if it doesn't go the way they want, they're going to get respect for accepting it and moving on. Whereas probably not so much if they start getting upset and arguing.
Now, another thing is they may see that their score that they thought they got and the score that was put in the system doesn't look quite right. They are allowed to go and ask for the scorekeeper to review what they've put in case there has been a mistake made. But that, again, is the kids, not the coaches.
Yeah, and that happens reasonably often too. I'd say maybe once every 2 tournaments, there'll be a mistake like that made. Not usually a huge deal, but just have the kids double check it in their brains and make sure it works. Okay, well, we're going to go now and deal with the rest of what's left of our day. So I hope this was useful to you all. If there are any questions or your kids want to ask things or just have the teams connect with each other, put something up on Slack or email us. The more teams talk to each other during a season, the better they all do. And some of us are going to get the option to go international next year. And we all want whoever that is to be a strong team and not be in a situation where we made all that effort and then got our butts handed to us. So we want to go in there and feel competitive. We're probably still going to get our butts handed to us, but at least we feel a bit better about it. Okay, everyone. So we will see you all around.
Once this is linked up to the YouTube and process, we'll send out those links and we'll link to the slides on our website.
No worries. Okay, so good afternoon, everyone.